Good afternoon, dear ladies and gentlemen. Would love to welcome you to this Senior 4 Virtual Mathematics Seminar. We want to thank the Ministry of Education and Sports, Holistic E-Learning Platform, UICT and RENU, who are collaborating to ensure that the learning gap is closed across the schools in this country. We want to thank them so much for the support and everything they are doing to ensure that our schools access the learning materials, that our schools are able to collaborate, and at the end of the day, to have our children acquire the best education. So in our agenda, we shall have some opening remarks, and then we shall have the word of prayer. Then we shall have the principal from the Ministry of Education and Sports, and then we shall go and dig deep into our seminar discussion. And in case of any questions, then we shall ask those people who have questions to go on and ask. So be free. That's what we are going to be looking at as our agenda for today. And we hope that within 3 hours, we shall have completed a lot in this session. Allow me now to invite any volunteer from any of the schools that wishes to lead us in a word of prayer. Raise up your hand, and then you take us through the word of prayer. In case your school wants to lead us in a word of prayer, in case you are the one who wants to lead us in a prayer, kindly raise up your hand, and then you take us through. Any volunteer from any of the schools, any learner, any child who wants to lead us in a word of prayer, kindly raise up your hand, and then you pray for us. Okay. I want to, okay. Madusi DSS, kindly get us one child to lead us in a word of prayer. Madusi DSS, kindly unmute, and you get us one child to lead us in a word of prayer.
Good afternoon to you all. My name is S.4 Junior, a student from Madusi Secondary School from Senior 4. Are you hearing me?
Yes, you are very clear. You are very clear.
I will request you to humble yourselves for the word of prayer. Dear Lord, we thank you for this afternoon. We thank you for this online gathering, dear Lord. Yesterday you taught us very, very good. I request your Holy Spirit to come back again and teach us in the same way. Let we learn something very different from the one we learned yesterday. I also call upon your Holy Spirit to guide those who have not yet come to also come early, not to lose anything. I've prayed through Jesus' name. Amen.
Amen. Thank you so much, Madusid SS, for the word of prayer. And thank you so much for joining in this session. I'd love to thank and all the schools that have joined this session. Thank you so much for joining, but also the students that have joined. Thank you so much for sacrificing your afternoon. Thank you so much for sacrificing everything to say that you can join in and learn. I want to just give you one assurance that all the sacrifices that you are making, they are going to pay off at the end of that day. So be assured that these sacrifices that you are making, they are going to pay off. And at the end of that day, we shall be able to celebrate together when you have your A's in mathematics. In this seminar, we want to help we want to ensure that by the time you leave this seminar, there is a lot you have learned. And we want to assure you that we shall give the best we can, and the schools that schools have already prepared. In case you have any question, kindly you can have it in the chat, or you can wait for the school to first finish their presentation, and then you can come in, and then we can be able to respond to those questions. So in case of any questions, kindly feel free to ask, but let us first wait for the school to finish the presentation, and then afterwards you can be able, your question will be able, we shall be able to answer it. Allow me now to welcome the principal from the Ministry of Education and Sports to talk to us. Principal, you are most welcome.
Thank you, Mr. Kaziba. Can you hear me?
Yes, you are very clear, Mr. Ronald.
Okay. Good afternoon, dear students. Good afternoon, teachers. And good afternoon to everyone who is joining us this afternoon. I'm happy that we are back here today. We had a good day yesterday, and we thought it wise that since Saturday, eliminate some of our friends from Adventist church section, we should be able to put up Sunday to try and accommodate them. So I'm happy that we are having this engagement this afternoon. My name is Ronald Dungu from Ministry of Education and Sports, and I sit at Legacy Towers, Government Secondary Department, and I'm also in charge of secondary schools in West Nile and Acholi region. But I also coordinate the deployment and transfers of teachers from government secondary schools. So I'm happy to be here listening in. I'm principally a physics math teacher, but now I do more mentorship for teachers. So looking back at the engagement we had yesterday and looking at all these online seminars and the reason why we put up these seminars, one of the facts that we have is that we are now having the new lower secondary curriculum. And that curriculum, its implementation can become very difficult if we do not collaborate, if we do not work together, if we do not research and share our knowledge together. So I want to encourage all the schools to continue in this collaboration, into this research and sharing, so that we can make the implementation of the new lower secondary curriculum very easy and quick for everyone. Going to the advantages of the seminar. Yesterday we had over 200 schools joining in, and you can see that that is very, very good because technology helps us work together. And I noted that there was a lot of patience exhibited from the different participants, listening carefully and allowing the presenter to make their presentation, and then they ask the questions later. In the chat, the language was good, and I want to encourage that when you're posting something in the chat, please make sure that your language is the language that we expect to read in that chat. There was also a lot of teamwork exhibited. We saw schools having more than one presenters. Somebody presents the first part, the other one presents the second, and then somebody else comes on to present another. But also we saw case studies where somebody is writing while the other one is making the presentation. So that teamwork is very good. And we encourage you to develop such teamwork in your schools, because our new curriculum spells out that teamwork is one of those critical skills that we must develop. We also saw a lot of presentations, different forms of presentations. We saw people using the Blackboard. Some people are using the PowerPoints. And then we saw people using highlighters. So you could see the use of technology and also combining with our traditional form the blackboard. And that is very good because it shows that our schools are moving. We are moving from the traditional and going above the usual. So I would like to encourage our schools not to forget the use of technology in our work, because when we're in COVID, we were all online. And when we went out of COVID, it looks like many of us forgot the change that we needed to have. So these seminars remind us and they help us to keep track of the use of technology in our teaching and learning process. So I want to congratulate all the teachers who have enabled us to come online, all the schools, the head teachers, for the money you're committing in form of data, the time you are giving us. And I know that Mr. Kaziba will be telling us about the program for the evening lessons that are going to start somewhere in July. We need to come in as schools and learn together. So I'd like to call upon teachers. If you're a teacher and you can teach a certain subject online, and you think you've done your research and you like to teach the students of this country, please volunteer. We don't have money. Ministry of Education doesn't have that money to be paying you to teach a lesson, but we want you to volunteer for the betterment of education in this country. And we are going to be creating a cohort, a group of teachers who are willing to support this country, the education in this country, so that we become one and we work together to develop ourselves, and then we go out and support the education in this country. So register with Mr. Kaziba. Mr. Kaziba will be giving you a registration link so that you join our team, and then let us work together to better the education in this country. To the students, we shall always do whatever it takes to make sure that you excel. You are in different schools, but you are the same student for this country. And we have one country, we must have one education. And as a Ministry of Education, we yearn for quality education and sports in this country. With those few remarks, I want to wish you the very best this afternoon. I will not be able to be here full time, but I will be joining you when I can and follow the discussions. I hope to meet you when we are doing the evening classes, and hopefully your teachers will make it possible for you to join in. Thank you. And thank you, Mr. Kaziba, Holistic E-Learning Platform. Thank you, UICT. Thank you, Renew, for making this possible. Thank you, and over to you, Mr. Kaziba.
Thank you so much, Mr. Ronald Dungu, for the remarks. But I'm seeing a hand up here. I want to take it on first. Yes, Kainavi Secondary School. Okay. Karinavili, was it?
Good afternoon, sir.
Yes, good afternoon.
I think it was a mistake, but I was just asking. My concern was, why are we going to do? I hear that after our lot, we are going to do old curriculum in HSC. Why is it like that? Because I feel like it will be of a big disadvantage to us from new.
It's not true that you will be doing the old curriculum. We'll have an abridged curriculum for the first lot, but the A-level curriculum is also changing. So you'll be changing, although the change is gradual, but you'll be changing. So you're not going to be totally doing the old curriculum. Thank you.
Okay. Thank you so much, Mr. Ronald. And I want to thank now all the schools that have joined in. Yes, I understand we may have some new schools that have joined in today, and I want to just throw a bit of light of how our discussion is going to run. You know very well that when the new curriculum came, the assessment changed, and therefore also UNEB changed the way it is supposed to set the papers. At the moment, the setting of the mathematics paper is set using what we call the elements of constructs. Elements of constructs means that all topics that are related are put into one body of knowledge. All those topics that have the same things are always put. And therefore, in the mathematics, we have mainly 4 elements of construct. And these elements of constructs are the ones that form our basis for assessment, are the ones that determine which area are they going to set in and which number should you expect. So the mathematics paper, has basically four numbers that we are supposed to attempt, and each of those numbers carries 20 marks. Therefore, the whole paper is out of 80%. Therefore, as a child, as a student, your task is always to ensure that you score highly in each of those sections. But in order for you to score highly, it means that you must have prepared very well for those given sections. And how are we supposed to prepare? We are supposed to prepare by doing as many questions as we can. And therefore, the 4 sections that are very important are numbers, patterns and algebra, data, and then the geometry. So when it comes to numbers, this is where our item 1 comes from. So our item 1 comes from numbers. Then under patterns and algebra is where we get our item number 2. Then under probability, we get our item. This is item 3 and item 4. And then item 5 will always come from geometry and measures. So item 5 and 6. So numbers have item 1, patterns and algebra, that is item 2. And then data and probability has item 3 and 4. And then item 5 and 6 come from geometry and measures. Therefore, when you are preparing, you are going to find out that under numbers, these are mainly senior 1 topics that you covered. So topics you covered in senior 1 are very important here. Take an example, number bases, working with integers, fractions, percentages and decimals, rectangular Cartesian coordinates, numerical concept 1 and 2, and then we shall have the ratios and proportions. But what do I want to emphasize? I want to emphasize the topic called ratios and proportions. Ratios and proportions is one of the topics that cuts across all the 4 elements of construct. You'll find that ratios and proportions can be found in patterns and algebra, can be applied under data and probability, can also be applied where we have geometry and measures. So this is one of the main topics that you as a student, you must understand, you must give your attention to, such that you can be able to score highly. So many of the questions that are being said can integrate in the knowledge of ratios and proportions. And that one will lie where we have the numbers. So under numbers and algebra, I want you to pay more attention. Okay, a minute. Okay, a minute. Okay, so I want you to give attention to that given part of the topic. It is very important, and I want you to give it more attention. So, okay.
Recording in progress.
Okay. Let me use this space. So please give it more attention such that we are very safe when it comes to that section of, So numbers patterns, and algebra. So those are the 4 major sections that we are going to be looking at. Those are the major sections that I want you to give your attention to, such that we can be able to pass highly when it comes to mathematics. Then the other section of data and probability, geometry and measures, it is also an important element or part when you are making your revision. So please make sure that you understand those topics. I know your teachers have done all what it takes to see that you understand them. So we are going to give them more attention such that we can be able to score highly. Allow me now to find out whether I want us to start with Our Lady of Good Counsel, and then after we are going to dive into St. Mark's College. So I want to find Our Ladies of Good Counsel. Are we set? Okay, so Our Lady of Good Counsel, they are going to take us through their first presentation. But like we have said, in case of any questions, wait for them to present and then we can come in and answer any questions. So any questions, anything that they are going to be attempting, we shall be making a summary at the end of that day. So Our Lady of Good Counsel, you are most welcome. Kindly go on and share your screen.
White screen. What is this? Share the screen. It's just no.
As Our Lady is coming on, I want to ask also St. Mark to prepare. And in case there is any school that also wishes to present, kindly be ready. You can send me a message in the chat. Kindly go on.
Good afternoon, everyone. My name is again Patience Sophia. I'm in Senior 4 from Our Lady of Good Counsel, Senior Secondary School, Gayaza. I am going to take you through the theme of data and probability. That is item 9. It's about the sets. The question reads, in a school survey, 220 students were asked about their internet usage habits. They were asked to choose from 3 activities: social media like Facebook and TikTok, academic work such as research and homework, and playing games. The results showed that 165 students used the internet for social media, 130 used it for academic work, and 100 used it for playing games. Among them, 70 students use it for both social media and academic work only. 60 use it for both social media and playing games, and 50 use it for both playing games and academic work. Additionally, no students exclusively use the internet for playing games. Now, the school needs to decide whether to set rules if more than 60% of the students spend their internet time on social media. Our task reads, calculate how many students use the internet for at least one of these activities. So I'm going to first start by collecting my data. The school survey was carried out on 200 students. I think the ones that took part in it. And then out of the 220, there were 3 activities that they used internet for. That was social media, academic work, and playing games. The results showed that 165 students used the internet for social media. So number of social media equals to 165. Then it continues, 130 use it for academic work. So I have number of academic work gives me 130, and 100 use it for playing games. $100. Then now among them, 70 use it for both social media and academic work. Number of socially. Oh, sorry. 70. Then 60 use it for both social media and playing games. And 50 use it for both playing games and academic work. Then additionally, no students exclusively use the internet for playing games, meaning that there is no student that uses the internet for only playing games, meaning that our set part of the games only, it's 0. It's 0. Now I'm going to represent this information on a Venn diagram. Oh. Then now, so that's my Venn diagram. I'm going to represent this information on it. So my mother said, so the number of the mother said, there are 220. Then the number of social media is 165. Then the number of academic work I have 130. Then the number of games, playing games, 100. Now, I have the number of social media and academic work only as 70. Then the number of social media intersection games, it's 60. But then I have to get the number of those who play social media, those who use social media and academic work, those who use social media, those who use the internet for social media and games only. So if you look at the question, you realize that they didn't give us the number of students who use the internet for all. Sorry. If you look at the scenario, we weren't given the number of students who use the internet for all the activities that were given. So it's going to be, I'm going to put it to be an unknown. So now meaning that the number of students who use the internet for social media and games only, it's going to be 60 minus X. Then the number of students who use the internet for playing games and academic work only is going to be 50 minus X. There we go. Then the number of students who use the internet for only playing games, it's 0. Now, I'm first going to go aside and work out the remaining parts because I can't work them in the Venn diagram. It's going to overcrowd the Venn diagram. So, I'm going to get the number of those who use internet for social media only. Going to be 165 minus, I open a bracket, 70 plus X plus 60 minus X. I have a positive X and a negative X, so those two X's will cancel. So I'm going to remain with 70 and 60 only. So it's going to be 165 minus 70 plus 60. When you add 70 and 60, you get 130. So my answer, when you subtract 165 minus 130, that's 35, meaning that 35 students use the internet for social media only. Now I also go ahead and I get the number of students who use the internet for academic work only. I want to know on my screen. It's going to be the total number of students that use the internet for academic work only minus, I open a bracket, 70 plus X plus 50 minus X, I close the bracket, 130 minus, I also have a positive and a negative X here, so it will cancel, 70, so it's going to be minus 70 plus 50, giving me 130 minus 120. Yeah. Okay. So 130. No, it's not mine. Someone is playing with me. 130 minus 120 gives me 10.
I wanted to share again.
Check back. I want to write. So I found out that for games only, it's 10. Now, calculate how many students use the internet for at least one of these activities. So in order to get the number of students, they're asking us how many students at least use the internet for something. So in order to get the number of students that use internet for at least something, I'll get the number of students that use the internet for social media only, those who use it for both social media and academic work, and also those who use it for academic work only, plus the intersection, that is our X. So I'm going to get, but if I have an unknown in the Venn diagram, so I'm going to first begin by getting that unknown, which is the X. That X is for the intersection part, the number of students who use the internet for all these activities. So in order to get them, now I'm going to get the value of X. The value of X. So I'm going to have 60 minus X plus X plus 50 minus X plus 0 gives me 100. So from here, I'm going to collect the like terms. I'm going to have 60 plus 50 plus X minus X minus X to give me 100. Now 50 plus 60, that is 110. So I have a positive X and a negative X. These two X's will cancel. I'll remain with minus X, giving me 100. Now I'm going to take the 110 the other side by subtracting on both sides. So I'll have 110 minus 110 minus X gives me 100 minus 110. So, of course, this one here will go. I'll remain with negative X, giving me 100 minus 110, that's negative 10. I will divide both sides because I can't have a negative value of students. You can't have negative people on a Venn diagram. So I'm going to divide both sides by negative 1 to cancel the negatives, by negative 1, by negative 1. So the negatives cancel, they become a positive. Then I have my X as 10. So that's the value of students that use the internet for all the activities. Now, after getting that, let me include it somewhere. But remember yesterday I told you not to overcrowd the Venn diagram. I just did this to show you how I was going to get the values. But all these workings in your Venn diagram, you should have a maximum of one unknown, and that is only the X. But after getting the value of X, we can now work out the value for students who use the internet for social media and playing games only. So I'm going to have, let me get the number of students who use the internet for social media and playing of games only, which is going to be 60 minus X. And remember our X was what? 10 minus 10 to give me 50. Then I also come this side, I'll get the number of students that use internet for academic work and playing games only, only. So it's going to give me 50 minus x, and this is 50 minus the value of x, which is 10, giving me 40. So 40 students use the internet for both social media and academic work only. Then after finding that, I think now we can go ahead and determine and answer the test. That I'm going to begin with A. Calculate how many students use the internet for at least one of these activities. So I was telling you that these students here, the number of students they're asking, they at least use the internet for something. Out of the 220 students, at least some of them, sorry, at least they use the internet for something. Like they're not just there, at least they do the internet with something. So I'm going to get, this is now my A. So number of students that use the internet for at least one of the activities, that is going to be 35 plus 70 plus 10 plus 50 plus 10 plus 10 plus 40, then the 0, even though you don't include it because none of the students uses the internet for playing games only. When I add this, I get 215 students. This is my part A. Part A, now we go to part B. Determine how many students use the internet do not use the internet at all. Meaning that out of this, the survey they carried out the survey and 220 students participated. But out of those 220, I think there are some that didn't use the internet for anything. So in order to get the number of students that didn't use the internet for anything, remember in A, we got the number of students that use the internet for at least something. So we're going to get 200, the total number of students minus the number of students that use the internet for at least something. So now this is part B. Students who don't use the internet. So the students who don't use the internet, I told you I'm going to get the total number of students that participated in the survey minus the number of students that use the internet for at least one of the activities, which is going to be 220 minus 215. When you subtract, you get 5 students. So 5 students don't use the internet at all. They were part of the people they carried the survey on, but then they don't use the internet for any of the activities. Then now I go to part C. Estimate the percentage of students who use the internet solely for academic work. Now, the number of students that use the internet for solely academic work. I don't know if you guys, if you can see my Venn diagram, on the Venn diagram, I have that set for academic work. But on that set for academic work, 130 students use the internet for academic work. But now from our question, they want the percentage of students who use internet solely for academic work. So meaning that we have to get out of the 220 students. There are those students that use the internet for only and only academic work. They don't use it for anything else. So they need the percentage of those students. So out of the percentage of students who use the internet for solely academic work. It's going to be the students that use the number of students that use the internet for only academic work, it's 10 from my Venn diagram. So it's going to be 10 out of the total number of students that use the internet that the survey was carried on, which is 220 times the percentage, that is 100%. This 0 goes with this 0. When you multiply, you get 100 out of 22%. When you divide, you get 4.545%. So this is the percentage of students that use the internet for solely academic work. Then now, then now I'm going to do part D. And part D says, based on the findings, advise the school on whether to implement the rules or not. On the last part of the scenario, it reads, now the school needs to decide whether to set rules if more than 60% of the students spend their internet time on social media, meaning that they have a limit. Okay, maybe the school administration wants to set rules, but in order for them to set rules, they are going to take a specific percentage, like maybe that is the limit. So if they find out that out of the students that the survey was carried out on, if it exceeds 60%, meaning they'll have to set the rules. And if it's below 60%, maybe they'll reconsider and they won't put there any rules. So now, in order to get the number of students, the percentage of students that, in order to get, we are going to help the school administration in whether to implement the rules or not. Meaning that before you advise someone, you first have to calculate. We are going to first find out the percentage of students that use the internet for social media. Now, for social media, we are going to get the total number of students that use the internet for social media out of the total number of students that the survey was carried out on. And if you got the my Venn diagram, from there, as you can see, there are 165 students that use the internet for social media. So in order to get the percentage of students that use the internet for social media, I'm going to have 165 out of the total number of students, that is 220 students. Then I multiply it by the total percentage, that is 100%, to get the percentage of students that spend their internet time on social media. So it's going to be 165 out of 220 times 100%. This zero goes with this zero. When you multiply, you get 1,650 divided by 22%. And when you divide this, you get 75%. So meaning that 75% of the students spend their time on social media. So now, remember, in the new curriculum, you have to advise someone based on your findings. And the school had set a limit that is 160%, meaning that they didn't know the percentage of students that were using the internet for social media, but then now they had set a limit of 60. If you go back to the question, 60%, meaning that if the school finds out that the number of students using internet is above 60%, they're going to do what? They're going to set the rules. But if it's below, they are going to maybe reconsider. Now, after calculating the percentage of students that use the internet for social media, I got 75%. Now, 75% of the students that the survey was carried out on use the internet for social media, meaning that from here, we are going to tell the school. Now, from here, we can tell the school that, yeah, it's okay if your limit has been crossed, so you can set the rules. So 75 is above 60. You can see. So you have to set the rules. So now you tell them, but before, remember the question was asking you, you advise them. So you yourself, you didn't know whether to advise them, whether to set the rules or not. But after carrying out these calculations and getting the percentage of students that use internet for social media, we can now advise the school that, yeah, the percentage of students using internet for social media is slightly high. So you have to set rules in order to minimize it. Thank you. That's why I end. Any questions?
Okay, kindly take me back to your first screen. Take me to your first screen. And let me test and see whether I can be able to write from my ends. Take me to the first page. So your first page. Okay. I want to just test. Oh, okay, I think I can write. Now, dear schools and dear children, whenever you are attempting this set theory, one of the key things I want to emphasize is always define what you are using. She has defined that A is this, G is this, S is this. But your first opening statements should show us what is S standing for, what is G standing for, and what does S stand for. So your opening statement should be that let me say S stand for the children who spend their time on social media. Let A stand for children or learners who do this and the other. Let G stand for children who use the internet for this and this. Before you go on to give your summary, this summary she has given us, first let us, what does the letter you are using stand for before you go into your final summary? So please Remember, we are looking for the excellence mark. We are looking for the coherence, for the flow of your work. So when someone sees S, he can interpret it differently. That maybe it means this, and the other. So let us not create debate on our answers. Let us always give an answer, but which has a meaning. Let us always define the different letters we are going to use. For universal, this one is mathematically known. So for it, it is very okay. But things like S, things like A, things like G, they may not be known. And for these questions that involve, they will not be defined for you. So you must define them yourselves and see what they do mean. So please always start with defining what you are going to use. Okay, kindly give me, I want you to take me to a new slide. So just continue. I want a new page where you can write. Okay, fine. It is okay. Leave it there. Now, what do I want? Now, when we are dealing with these Venn diagrams, at times we may mix words and symbols because we want to find out, did you understand the competence when you are looking at sets? So we can easily even tell you, or we can easily just give you the symbols for one of the numbers. So you as a student, do you know what it means? So I want the teachers and you, dear students, when you are revising, when you are making your revision, there are some key things that they may bring that are not so common, but when you must know them. Take an example. This is our set ABC. When they give you this region, do you know where it lies? Do you know what it means? So I want you to give attention to some of those key things that are not so common. At times they can set it like this. At times they can just say AB union C and everything complement. If they tell you that this is equal to this, do you know where you're going to place it? So this is one of the common things, but it's not so common. It's not easily said, but it can also appear. So you need to know where does it lie. So when they give you such a region, you need to know where it lies. And that region stands for those who don't like any of the three. So someone may want to confuse you to check out your understanding of set theory, and yet you don't know. And you failing one of these, it may make all your answers wrong. So whenever you meet such thing, it's not something very common, but give it some attention. That one stands that those students don't like any of the three. And it comes from what we call the Morgan's rule. So whenever you find such thing, it means that those are the students who don't like. So this space here of the one I'm putting blue, it means that those students don't like any of the three. Number two, I've talked about one, when you are attempting these numbers, first summarize the way she did. As you are summarizing, the first thing you do, you define what you are going to use. So first define what you are going to use. After defining, summarize the items that have been given to you. Now, after summarizing, go on and represent it on a Venn diagram. Draw your Venn diagram. And when you are drawing the Venn diagram, please use a compass. Don't draw using your free hand and you do like this. No, be organized. Remember, you are looking for the excellent mark. If they're giving that excellence mark, do you think someone who has used the hand will get that mark? You'll miss it out. So let us not lose marks because of our carelessness. So use your compass and draw a good circle. So never use your free hand to draw the circle. And here, if possible, feel free to use either pen or a pencil, depending on which one is easier for you. So after drawing your Venn diagram, feel free now to put all the things you want the way you have summarized them. Then please take note. For words, you are going to find words, or they are going to be bringing words. And in those words, whenever you see the word only appears. So we expect that where there is only, we shall expect you to have a complement when you are summarizing. The moment you see the word only, let me say they say those who like A and B only. So we expect that when you are summarizing, you can say A and B only, or you can put it mathematically, A intersection B intersection C complement. So we expect that when you are defining only, where there is something only, we expect you to have a complement. The same thing will appear whenever you meet a negative phrase. There are some negative phrases that do not. So such things, we expect you to have a complement when you are summarizing them. Remember, when you are summarizing them, you are trying to avoid having the let me say, you are trying to reduce on the words in your attempt. So we expect you that for such, you always use the complement. So for those negative phrases like do not, where you meet only, we shall expect you to use a complement. However, whenever you meet words that all appears, the word all, when it comes to set theory, this one will mean union. And when you meet the word, so when you meet, we expect a union set. When you meet the word all appears, we expect you to use a union set. However, when you meet the word any represents, so when you meet where the word any represents a complement set of the union set. So please be very careful when you are solving such a question. Another word they can use, at times when they don't use the word only, they can use the word exclusively. So when you meet that word exclusively, also it stands for only. So it might not be something very common, but you never know. They can trick you and they say exclusively. So when you meet it, please make sure you give it more attention. Another thing I want us to pay attention to is that when you are calculating this set theory, all these numbers about sets, it is very hard for you to come up with a negative answer. So whenever you meet a negative, please question yourself, check through your work and see, is there any mistake I have made? And also, I want, like yesterday we said, you must use critical thinking. Ask yourself, do we have negative people? In case they're about people. In case they're insects, do we have negative insects and the rest of that? So please, whenever you meet a negative in your answers, please make sure you cross-check before you make a conclusion that there is a mistake. And do not hurry to say there is a mistake, there's a mistake. No, there are no mistakes. We can have mistakes, but those mistakes are always corrected earlier on. So whenever you're making any calculations, please make sure you do the needful. Then the last one is going to be on the percentage. Many of these questions, they involve in probability. And probability at times can be asked in percentages. When you are giving a percentage and you find out that your percentage you have got is a decimal point, let me say you have got your answer as 75.3234, something like that. Always when you are writing your final answer to probabilities, make sure you write to at least 2 decimal places, at least 2. So for such, your answer can be 75.32%. In case it is maybe 75.3, in case maybe it was 589, you can say 75.36%. So make sure you write to at least 2 decimal places. I told you, you must always avoid what you call premature approximation of the answers. Okay, thank you so much. I think then I think the last thing I want to throw more light is going to be on your conclusion. Please and please, when they ask you, let me say, when you looked at part A, they were asking those students maybe who take only one, who use the internet for only maybe social media. Please, when you're concluding, don't just state that it is five students. No, make a good statement that the number of students who use the internet for social media is 5. The number of students who take all the 3 subjects is 10. The number of students who do this and this is this. Because remember, in real life, when someone asks you, you must always respond in words. You cannot say, let me say, your teacher asks you, what is the distance to home? You say 5. No, you must be able to say that the distance from home to school is 5 kilometers. So please conclude in words. Because it has been asked in words, also conclude in words. So say the number of students who take this and this are 5. So 5, you can write 5, it's okay. That's what I'm saying. So, but write it in a statement form. Otherwise, I want to thank Our Lady of Good Counsel. Thank you so much for this presentation. That is what I wanted to, that is the submission I want to make. Thank you so much for that wonderful presentation. I want to find out, do you want to first take us through the second number, Our Lady? Or we can first go to another school. Our Lady, you can let us know. Our lady, I beg your pardon?
So
Are you ready?
For the second number, I'm going to take you through item 16, me and some other colleagues. So the number is, your neighbor runs an industry. Your neighbor runs an industry in a shed that is in the shape of a cuboid, surmounted by a half cylinder. The dimensions of the cuboid base are 15 meters by 7 meters, and the height is 8 meters. Your neighbor wants to install air conditioning units in the shed. The installation company offers two types of units, type A and type Y. Each type X unit costs US dollars 2,500, and each type Y unit costs US dollars 3,200. The type X unit covers 100 meters cubed of air, while the type Y unit covers 150 meters cubed of air. For bulk purchases, the company offers a 5% discount on the total cost for every 10 type Y units purchased, and a 7% discount on the total cost for every 8 type Y units purchased. The neighbor plans to buy enough units to cover the entire volume of the shed to buy the air conditioning unit, but is unsure of the amount needed. Task A, find the volume of air that the shed can hold. So I have another colleague that is going to take us through part A.
Good afternoon to you all. I am Muhaya Lydia Michelle from Our Lady of Good Counsel, Senior 4. So for part A of that very particular item, we are going to first find the volume of the cuboid. So to find the volume of the cuboid, volume of the cuboid is length times width times the height. Volume is equal to the length, which is 8 meters, times the width, which is 7 meters, times the height, which is 15 meters. Oh, sorry. Sorry for the... The length. So, So our length is 15 meters times 7 times 8 in bracket cubic meters. So our volume is 840 meters cubed. So I'm going to volume. So since the top of the figure of the diagram is cylindrical, but it is a half a cylinder, it's not a full cylinder. So we are going to get the volume of half of a cylinder. So the volume will be a half times pi r squared h, which will be a half times 22/7 times 3.5 squared times the height, which is 8. So for this radius, so the diameter at first was 15. So the diameter at first was 7 meters. When we divided it by 2, we got the radius, which is 3.5. That's why we have 3.5 here. Then our height is 8 meters. So the answer is going to be so to get the volume for the total, volume for the whole figure, we are going to add this volume of the half of the cylinder plus the volume of the cuboid. So total volume is volume of cuboid plus volume of half of the cylinder. What's the volume? Volume is equal to 840 cubic meters so pardon me please on this value for the volume. It is supposed to be 2,887.5, which is so yeah, I've corrected that one. So when we come back here to the volume, the total volume, the volume of a cuboid is that, then plus the volume of half of the cylinder, which is 2,887.5 meters cubed, which gives us 3727.5 meters cubed as the total volume of the figure. So let me introduce my other colleague to take you through part B of the question. So good afternoon, everyone. Yes, I am Priority Nawanka from Our Lady of Good Counsel. Yes, and I'm discussing part B for you. Part B is if the industry requires machinery which would occupy a total space of 300 meters cubed, and there are 20 workers of whom occupy 0.08 space on average. How much air would be in the shed when it is working? So we are told that the machinery is 300 meters cubed. So we're going to use M. Sorry. So we are going to use M is equal to So we're going to use M is equal to 0.08 meters. Yes. So that is grab everything. Sorry, once again, our M is the machinery, and it is going to it occupies a total space of 300 meters cubed. So M is equal to 300 meters cubed. 300 meters cubed. That is for cubed. Then the workers, we are told they are 20. So the workers are going to be W. It is equal to, there are 20 of them. 20. And each occupies 0.08 meters. 0.08 meters. So with that multiplication, if you use your calculator, you get your answer as 1.6 meters. Meters cubed. So we are going to total this. We are going to total this up. The answer we got for the machinery. So we are going to use the answer we got for the machinery and then add it to the one for workers. Yes. So the total is equal to 300 plus, the total is 300 plus 1.6, which will give us 301.6 meters cubed. So we are going to find the volume of air left, which is the total volume from the cuboid minus this occupied by the workers and the machinery. So we are adding we are subtracting 1, to 8.75. The answer Michelle gave us minus this total, which is 301.6 meters cubed. So with that, we'll get our answer as 827.15. Yes, bear with my handwriting. So that's our answer in meters cubed. Yes, thank you for listening. So my other colleague, Paris, will take you through part C.
My name is Abel Praise from Our Lady of Good Counsel, and I'll take you through part C. So, our part C says calculate. Our part C says calculate the number of air conditioning units required for both type X and type Y units based on the usable air volume. So,
No, that's
so type X. Wait, one unit. One unit of type X is 100 meters cubed. So from our original volume of the shed shall have 1,128.75 meters is gonna give us 1,128.75 over 100 times 1 unit. We are doing this to get the number of units of types X used to cover the shed. This will give us 111.2875 units. This is approximately 11 units. So for type Y, type Y, 1 unit meters cubed. From the 1,128.75 meters cubed. So we shall use 0.75 over the 150 times 1 unit. This will give us 7.525 units. This is approximately 8 units. And that's the answer for part C.
Good afternoon to you all. My name is Kids Faustin from Our Lady of Good Counsel, Senior Secondary School, Gayaza, Senior 4. So my colleague is from doing part C, and I'm doing part B. As part B says, estimate the total cost and the amount of money your neighbor needs to borrow for purchasing the required air conditioning units for both type X and type Y. So from the presentation that my colleague made, for type X, we got 11 units, and for type Y, there were 8 units. So remember, in the question, we were given discount. Like for type X, the question for type X, a 5% discount is given for the total cost for every 10 type X units. But for X, we got 11 units, implying that, remember, for the giving 5% discount for only 10 type X units. So we are going to subtract 10 from this 11 so that the discount is given. And then the remaining one, we shall find the price for it. So 11 minus 10 is us 1 unit as the remainder. So we're going to first get the cost for the 10 units so that we can reduce the 5% discount. So 1 unit type X costs $2,500. So what about 10 units? This will be the same as 2,500 times 10. This gives us 25,000. Sorry, $25,000. But remember, we need to apply the 5% discount for this 10 units. So this means 5 over 100. This is the 5% discount that will be given on the 10 units. So 5 out of 100 times that $25,000. This in total gives us $1,250. Since the discount, we need to subtract it from the original $25,000. So meaning that $25,000 minus the discount, which is $1,250, to give us $23,750. So get remember, this is only for the 10 units, from which we applied the discount, but we still have the other remaining units. But we know that 1 unit of X is equal to $2,500. Sorry for the handwriting, but this 1 unit is, sorry, 2,500. So 2,500 plus this 23,750 will give us the cost for the units of type X. So we are going to add the $2,750 plus the $2,500 in order to give us the cost of type X. So this is $23,750 plus $2,500 to give us 26,250. Remember that dollars. So this is the total amount she gets for type X. Only now we want to find for type Y. If you remember correctly, my previous colleague got 8 units for type Y. And in the question, they are saying that type X units purchased at a 7% discount on the total cost for every 8 type Y units purchased. So we are going to first get the cost for the 8 units that we applied a 7% discount. This is type Y. So 1 unit of type Y corresponds with $3,200 as seen in the question. What about 8 units? 8 units are the same as 8 times the $3,200. So this will be that will be $25,600. So then we apply the 7% discount. 7% discount. This is 7 out of 100 times. Sorry, times the total code. So, sorry, if you use your calculators, the answer will be $1,792. So we got $26,250 for type X and 792 for type Y. But remember, for type Y, this is the discount, and we need to subtract the discount from the price of the 8 units. So this will be, we're going to get the $25,600 minus the $1,792. I'm going to put it on board, but the answer we'll get will be $23,808. This is $25,600 minus the dollars $1,792. The answer is $33,808. So that will be the cost for type Y, and the original cost for type X, which we got as $26,250.
So for type E, we decided that type Y would be better because one would save money. Yes. For example, when you look at our answers for part C, 11 units for type X were needed and 8 units for type Y are needed. So in conclusion, type Y would be best because it covers a bigger volume, saves money, and the discount is bigger. Thank you for listening.
Okay, thank you so much. Our lady, we have some questions coming in. Yes, let me ask Sapo. Ask.
So when you was finding the volume of a half cylinder, you have used the 5 of 8 instead of using 15. So for me, I think the answer is wrong. You better use 15 in order to get the correct answer.
Okay. I think our lady, can you take us to that slide for the cylinder? Okay. Okay. Unmute. Okay. Karinabiri, unmute. Okay.
At this moment, our leader of the council is changing signals. So please bear with us for some time until we come back to connection. Yeah, thank you so much.
Okay. Okay.
We are coming back to answer questions right away.
Hello? You are saying, our lady?
Yes, please.
Okay. I wanted you to take us, I want to make that observation because someone is saying you used, instead of using 15, you use something else.
Just take us is back online. Thank you so much.
Okay, kindly take us to that first slide.
The error was, yes, the error was with us. I think we mistook the height. The height is 15, but the answer, the one discussing forgot to change. But the height is 15 for the case to get the total given, not 8. Please correct that. Thank you very much for the observation. Have I answered the question?
Okay, okay.
Has it been answered?
Yes, it is fine. Okay. Now, let me now come in a bit. Okay. Now, the question, I think some schools were asking which questions are we answering. So we're answering that question of number 16. When you look at the seminar questions, it was number 16 that we are attempting. Now, when you look at number 16, this is the number that we have been answering. However, I want to Okay, this is the number that we have been attempting. Now, when you look at this number, it required you to use knowledge of mensuration, where we have those things of areas and volumes. So areas and volume, this topic, you mainly cover it in senior 2, and then you add on in senior 2, you cover some areas concerning areas and then the volumes. But when you look at this figure, it had 2 things in it. So it had a cylinder. So when you try to complete here, you can note that it was a cylinder. So this was a cylinder when you look at it. So when you look at this cylinder, one of the questions that now should come onto you is that they have asked us to find a volume. So I expect that when you are finding the volume for the whole of this solid, you say that the volume is going to be the volume of the cuboid plus the volume of the half cylinder. Because we know that to get the volume of the cylinder is always given by base area, then times the height. So when you look at this cylinder, when I try to extract it, being that it is a half, it means that when you are getting the base area, what you have is a half of a circle. So meaning that since the circle is not complete, it's just a half, then I don't expect that we are going to, so don't use now the full thing. Since the circle is a half, and we know that the circle is pi r squared, the area of the circle. Since the circle is half, then therefore it means we shall say a half pi r squared, then times our height. So that's why they used a half pi r squared. The use of a half is that this circle being a semicircle, the area of the full circle is pi r squared. But since now we are interested in just a half of it, then we shall always have a half pi r squared height, then times h. So that is the volume for this cylinder. But when you look at that cylinder, when it is standing up, you can really notice that the height is 15. So the error that they made, that the height was 15, but the radius, since you had 7 as the diameter, it means that for your radius, you must divide it by 2. So by dividing by 2, it means you have to get 7 divided by 2, which is 3.5. But this is where now I want to emphasize. Imagine that the number you were dividing with, imagine the diameter was, let me say, something like 11, let me say something that recurs, that has very many decimal places. So when you find that the number when you divide, you get a number that has very many decimal places, then for that case, leave your answer, work in a fraction such that you can get a good answer at the end that is very accurate. So whenever you find that the decimal is a recurring decimal, then continue working with your fraction. But when you find that the decimal is a terminating decimal with 2, 3 decimal places, then that one you can feel free to use it. But if it is a recurring decimal that goes on and on, like let me say a recurring decimal like 1 out of 7, and just imagine. So this will give you 0.1428 what. So for this one, to avoid errors, the best thing to do is work out with your fraction. Do not terminate it. But what is very important is the idea that they have given us. But still, when you look at what they have given us, I want you to pay attention to 2 things, because I may not talk about it again when it comes to business math. You have noticed that in this question, they gave us the discount. Therefore, when you are revising, I want you to pay attention that when they talk about discount, how many types of discounts do we have, such that you know that at times now this question, it can as well be mixed, whereby we bring in an idea of what? Of another discount, whereby now the discount, you need now to pay attention that discount, we have many 2 types. We have what we call the cash discount, and we have what we call the trade discount. So the question can be mixed, whereby they bring in those 2 ideas. Instead of giving you 2 suppliers, they can just mix up the discount. So whenever they mention that it is a cash discount, so cash discount means you are paying by cash. That's when you pay by cash. You go to the supermarket and you are paying by cash, and they decide to reduce for you. Then when it comes to trade discount, it's when you are buying things in bulk. So when you are taking up things in bulk, at times they give you what we call a trade discount. So get the how to deal with those 2 types of discounts. It can be mixed in the questions, and then you may get confused. The way we calculate them is a bit different. So pay some attention when it comes to discount. So it is very common when it comes to the business math. When it comes to that area whereby people, I think I will share a question. There was a question that was about eggs. The farmer was selling eggs, something like that. So I will share something such that at least you can have an idea of what we call the cash discount and what we call the trade discount. But now, when it comes to mensuration, please do not use your pi as 3.14. Never use your pi as 3.14 unless the question has stated. But now, whenever you don't see anything, please stick to 22 out of 7. Never estimate that it is 3.14. Always stick to the value, which is 22 out of 7. Don't go on and use other things. So please make sure you go on with that. Then lastly, I want you that always make sure that your work, when you're answering these scenarios, let it have that flow. Now, like the way you have seen, feel free to write those words that the total space occupied by the machine is this. The total space occupied by the workers is this. The air in the shed is this. So feel free to write the words. Do not just use symbols, just subtract without defining what you are doing. Define what you are doing. That now I'm calculating the total space occupied by the machine. I'm calculating this and this, such that your work has the logic flow, such that someone marking and following your work can easily see what you're doing. Now, which 2 figures do I want you now to take note of? 1, I want you to take note of what you call a cylinder when you are making your revision. Because these are some of the real life things that we meet. We meet cylinders in real life. Take an example. You have seen those gentlemen who usually carry, who remove soil from toilets, who carry bricks and the rest of that. At times they use those figures when they use some of those shapes when they are carrying. You have seen people in drums when they are carrying water. You're in the buckets. So you can find a bucket like this. So something like this. So please pay attention. So for these figures, know how to calculate their area, know how to calculate their volume, and also know how to deal with the frustrum, because they can tell that this is the bucket. You have seen people using a bucket to carry things. So this one can easily be set. So you need to know how to complete it and then find its volume. And do not forget that whenever you meet a cone comes from a cylinder. You know that whenever you have a cylinder, you can be able to form what? To remove a cone. And how do you remove a cone? I can come here and here. So I form a cone. And when I form a cone, you notice that we end up with 3 triangles. This is one triangle, the second, and the third. So that's why when it comes to the volume of a cone, you always have a third, pi, and the rest of that. So please pay attention. I've said a cylinder. I want you, when you are revising, pay attention to what we call a cone, and then pay attention to other quadrilaterals that we can meet in real life. So that is my submission on numbers concerning mensuration. Okay, but do not forget the units. Do not forget the units. In case it is meters cubed, stick to the meters cubed. In case it is dollars, stick to dollars. In case they have used UGX, stick to UGX. In case they have stick to shillings, use shillings. Please do not go on and use other units that have not been used in the question. Okay, thank you so much. That was Our Lady of Good Counsel. Thank you so much for the presentation. I'm seeing some question coming in from Yitula. Then let me ask St. Mark's. St. Mark. St. Mark, where is St. Mark? Okay, St. Mark. Okay. Okay. St. Mark is there. Okay. So I'm saying, Yitula, you can unmute. Ask.
Yes, thank you very much. When our sisters were discussing about question number B, we were unable to pick it due to some network problem. I don't know if they can help to come again with the calculations as well as B and C.
Which question? Part?
Question part C, B and C.
Oh, part B and C. Part B. Oh, okay. Now, you are going to allow, because the part B and C, we are talking about the calculating this total space, how much air would be in the shade when it is working. So what you need to do is first find what is the total space. You have the total space that is being occupied by the machine. So also calculate the total space that is being occupied by the workers. So to find the total space occupied by the workers, it means you're going to get the 20 workers times the space each of them occupies. So since it was 0.08 on average, so you'll get that space occupied by the workers will be 20 times 0.08. So you end up with 1.6 meters cubed. So to get the total air, to get the air in the shade, it means you're going to get the total minus, let me see. Okay, just a minute. Okay, but St. Mark, kindly just let me know whether you are ready and we start. Okay. Yes, Our Lady, you can come in. Our Lady. So for that one, you'll get something like 827.15. Okay, Our Lady, you can submit.
So teacher, when we were discussing this number as a group, we had issues concerning part C on the answers we got. For example, the original answer for type X was 11.2875. Then we were wondering, can you, like, are there point units? Then for part Y, we got 7.525 as the original answer. So after that, we had to round off. So, okay, my real question is, were we supposed to buy the extra type Y because of the point unit to facilitate them, or we were supposed to just truncate or something like that? Please clarify on that.
Okay, thank you. I think I just forgot to mention it. Now, like I told you, whenever you meet decimal places, you need to apply the critical thinking skills, because in the shops or in the shops where we buy things, always they don't sell half things. So meaning that you must buy a whole number. But still, when you look at the space that was supposed to be occupied, the space, when you buy a few, it means that the air inside, because they want, the reason as why they are putting in these cooler is because maybe inside it is very hot, maybe something like that. Those air conditioning, they want to improve, meaning that if it is less, their objective wouldn't be achieved. So when you put less than what they need, it means that their objective will not be achieved. So for this particular one, it was better you round upwards, such that that extra of 11.2 something like that can be catered in that extra one that you are going to buy. But when you buy the less ones, it means that there will still be a demand for more. So it was better you round up on that particular one. So, but always you reason on which one can work better. So for type X and Y, the air conditioning was better. You buy above, such that the objectives of the company are achieved. Because less than them, it means that the air still in the room, what they wanted, it will not be achieved. So more load will be put on the less that they have brought. Okay. Thank you. Our leader, I'm seeing your hand again up.
Yes, teacher, you mentioned the critical thinking skills, and in my opinion, personally, I feel, can we install, for example, now the space we have needs 7.525 units, right? So if we round up and we buy 8 units, will the 8 units, like, will the point be, okay, if we buy another, okay, we buy 8 units, yes? After buying the 8 units, we'll have nowhere to put the full units. So can we install quarter units and half units?
Okay, now then it means you come to the conclusion. Now, in your conclusion, that's where you need now to mention something of that nature. So you must give the reason as to why you have decided to round downwards or upwards. So that's why always they ask you for your own opinion. So alternatively, you can round one up and round another one down in order for you to be able to occupy them. But it depends on how you reason. Your conclusion matters a lot. Yes, and you can even offer, advice on what you think they can do. Okay. I want to invite St. Mark's College, Namagoma. Are you set?
So teacher, rounding down was correct.
Yes, both options are fine. Both options are fine. But the conclusion, make sure that in your conclusion, you reason out.
Thank you very much, teacher.
Okay, thank you. Okay, St. Mark's College. Oh, I'm failing to get St. Mark's College, Namagoma, they wanted to discuss. Okay. Okay, then there is a school there's a school, I think, that wanted to discuss. Okay, St. Mark's is here. Thank you. Thank you. Okay.
Authorizing. Yes, it's there. But you wish to present it like this. Well, you can do that in my computer. Yes, I wanted to.
St. Mark's, we cannot get you clearly. Okay, and I'm going to request that St. Mark, if you can first take us to question 17. To question 17. Yes, to questions. Then there's a school that wanted to discuss number 10. Kindly. The school that wanted to discuss number 10, kindly. Yes, I'm going to ask St. Mark's. You are going to first take us to number 17. I'm seeing you are off. They're off. There's a school that wanted to take us to the number 10. Kindly wait. Okay, question 12, Vula SS. Okay, Vula SS, feel free to come on now. Number 12, hope it has not. Vula SS, as we wait for Vula SS, you can raise up your hand as we wait for St. Mark's College to come back. Vula SS, kindly raise up your hand. I think you wanted to take us through number 12. Oh, number 12, I think, was done yesterday. I wanted a school. There's a school that wanted to take us through. Oh. Okay, there's a school. Okay, St. Mark's, are you back? There is a school that wanted to take us through one of the numbers, but because they are not here, there's a number that I'm interested in, and I want to throw more light, a number concerning linear programming. St. Mark's, can you first take us to that number 17 you have? Oh, St. Mark's. Okay, it is okay. They are still getting some network challenges, but let's give them some little time. Okay, but as they get on, allow me now to dive into. They are going to come on in a minute, but I'm going to dive into one part, and that is going to be item number 2. And on item number 2, I'm recording in progress. Okay. On Oh, sorry. I think my sound was off. Oh, sorry. Okay, allow me. Okay. 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 Now okay. Let me first stop the sharing and I share again. Sorry about it. I thought I was talking. So I was still saying that when it comes to, I wanted to share something on linear programming. And that's where I want to concentrate now. Okay, hope now my screen is on and you can hear me very well. Kindly just help me to know in the chat whether now I'm clear. Am I clear now? You can type in the chat such that I can know whether I'm good to start. Okay, good. So I'm clear. Now, I was saying that when it comes to linear programming, it is one of the items that is going to be very common. You're going to find this item a bit common in many of the papers. Reason being is that it has a wide application. It is something that we can apply in real life. When it comes to transporting things, it is one of the topics we can apply. When it comes to things of looking for how to maximize, how to minimize, then it means we need it. So linear programming, it is under item number 2, where we have algebra and patterns, where we have patterns and algebra. And under item 2, or under that element of construct, you have linear programming, you have loci. Now these topics I'm mentioning are some of the topics you must know as a student. I've said linear programming, you know your loci, bring in what we call equations. Under equations, look at quadratic equations, look at linear equations, how to solve them. And thereafter that, it means that at least you are somewhere. So how do we attempt these questions? Whenever you find a word problem on linear programming, first summarize the scenario you have. Summarizing the scenario will help you to know which things have been given the table, which things are changing in the table. That is what we call the summary. Summarize the scenario. In this one, we can use what we call the tabular format. Under the tabular format, you draw a table summarizing what has been given to you. Take an example. In case you are dealing with their cars, you can put cars. Maybe, let me say you have a car and a lorry. So summarize it like that. In case it is in foods, maybe they're talking about food, summarize and see what you have. Number 2, define the variables used. We no longer give you now the variables to use. It is you to define which variables you're going to use. When we talk about variables in math, those are the X, those are the Y, and the rest of that. But when it comes to linear programming, I want us to stick to 2 variables. That is the X and the Y. Why? Because these ones are easy to plot. You can easily plot them on your graph. So you here start by saying that some of the opening statements I want to see you start using. Let X represent the number of lorries. Let Y represent the number of this and this. By doing so, it means that you know what you are going to do. Number 3, write the mathematical statements. So when it comes to variables, let me go back a bit. Avoid using things like let lorries be represented by L, let cars be represented by C. This one it is very okay. It is mathematically correct. But the moment you come to drawing your graph, you are going to get challenges because you may fail to determine what is your L and what is your C. What am I going to put on my X and what am I going to put on my Y? So you may find challenges when it comes to that. So please, you must be very careful with it. Number 3 is what you call the mathematical statements. The moment they tell you a mathematical statement, here they want us to write what we call the constraints. Constraints is what they are looking for. They are looking out for those kind of equations. that you have extracted from the word, and now you're writing it mathematically. And at this point, write all the equations you know. Do not limit yourself, because they are not going to specify that write 5, write 4. No, for you write as many as you can, but start with the ones you are very sure, and then write the rest, such that someone marking can be able. And when you are writing, be specific. In case you are talking about, let me take an example on one of the numbers we are going to do. One of those numbers that we are going to try out on linear programming. Take an example. Let me say I want to be sure of one of the problems. Be very sure. Let me say workers' constraints. Then you write it. Write that equation. Maybe it is about capital constraint. Write that one. In case it is non-negativity constraint, write them. So be specific what you are writing. Don't just write x plus y greater or equal to 0. X minus y less than 5. Like that. No. Define what you are constructing. What is it that you are writing? That I'm writing about the transport constraints. I'm writing about this and this, such that you are very sure of what you are writing. So that's what we call the constraints. So clearly define what you are doing, such that at least someone can be able to follow through your work. After doing so, you are going to form your inequality. Make the inequalities equations. By making the inequalities equation, it means that in case you have generated your constraint as x plus y is greater or equal to 5. Now, before you draw it, first make it an equation. An equation must have an equal sign. So say x plus y is equal to 5. Is now transform it into an equation. And after transforming it, that's when you can come up and then have your table of values. Have your table of values, x and y. Then start putting in the values you want to plot, such that you can continue. So please, and here, why do we want a table? A table summarizes many of the things, and you use here little time for you to complete your work. Then shade what you call the unwanted region. They may not specify for you that whether shade unwanted or wanted, but the moment they have not specified for you, then it means that the unwanted region is the one that you are going to shade. Why? Why do we shade the unwanted region? Because when we are looking for solutions, we always use that feasible region. We always use the wanted region. So meaning that if you shade it, will you be able to read the values? So you will not be able. So always stick to shading the unwanted region. The region that does not satisfy the inequalities, that is the region that you should keep on shading. Then extract what we call the integral values. Remove those integral values. And when we are extracting the integral values, it means that we are extracting the whole numbers. Do not extract points. Extract those whole numbers. And then when you reach that point of summarizing them, please go on and summarize them in a table format. Why do we use a table format? In a table format, here you minimize the space you are going to use when you're making your calculations, but still, even your work looks to be very organized than someone who's just working out points from different parts. So summarize and make sure you have your well-organized table showing the integral values you have extracted, and then after you can be able to fill them into your objective function. So take an example. In case you are extracting your values and maybe you have finished to draw everything, then in fact, even you are going to write, in case the question is about maximization, say maximization of maybe the cells. So draw your table. Let your table be clear and say, these are my optimal points. And what are my optimal points? Then put that x and y. Then say, what are the cells? The cells is what we call the objective function. The function that you are going to fill in order for you to know how much profits, how much sales have you made on that particular day. And when you are writing the optimal points, always you write them in coordinate form. We write a coordinate that may be 10, 5, but don't just write 10, 5. This one is not a coordinate. This is just a comma. It means 10, it can be 5, 0, or negative 5. It can be something like that. Someone may interpret it. So when you're writing a coordinate, put the bracket. such that someone knows that you have extracted a bracket. Even if you don't be so careless and just write 10, 5, 5, 3. No, these are not coordinates. These ones can be, in fact, even someone can take them as sequence. So please be very careful on when you are doing so. So then another thing I want to put emphasis is going to be on the graph. The graph always carries a lot of scores, meaning you must maximize. And now for this time round, what are the sum of the good qualities on that graph that you are going to draw? One, include the title on your graph. Say a graph showing the feasible region. That is the title on the graph. After that, somewhere indicate the scale. What does the scale say? That maybe I'm going to say my scale is 1 centimeter represents, maybe in case you are dealing with workers, represents 1 worker. That is along the horizontal. Maybe 1 centimeter represent maybe one unit of capital along the vertical. Put your scale somewhere. Don't put it on the graph because it might if you want, you can put it somewhere, but I don't want it to be on the graph because it might make your graph a bit, you may need that space where you're going to place it, but put a title and then put a scale somewhere. What does this 1 centimeter represent? Does it represent 1 car? Does it represent 5 cars? Does it represent 5 cows? Does it represent this and this? So put the thing, and then label your axis very well. Label that this is my y-axis, and here indicate along it that this point here means, or along the y is where I have my cars. Along the horizontal, label it that this is the x-axis, but along the x-axis, what do you have? That I am having the lorries. So name it very well. Don't just say y and x and you stop there. Put what does the y-axis represent? What have you plotted along the x-axis? That they are workers. What have you presented along the x-axis? That it is this. So don't just write y and x and you stop at that point. So please label it very well. So that is briefly about that. Now, what are some of the common statements that you are going to be finding when it comes to this kind of thing? Now, one of them is going to, okay, I'm scrolling. Okay, allow me. Okay, I think I'm there. Now, some of the common phrases you are going to be finding when dealing with linear programming, and these are the ones that are very key. The moment you understand these words, the meaning, it means you are very good to go. One, you are going to be finding these words. All these words I've written, they mean the same thing. When they use the word less than, now you need to know, what does less than mean? Less than. That is what you call less than. So in case they don't use the word less than, they'll use fewer than, lower than, smaller than, shorter than, below. So the moment you see any of these words, all these words means less than. So the moment you meet it somewhere, just know which inquiry am I going to use. They can say the number of cows are below 5. So when you say below 5, it means I'm going to say x less than 5. The number of cows are shorter than maybe this and this. The number of people were less than. So for you, the moment you find any of these words, then you need to know that the inequality sign I'm using is a less than inequality. So all these inequalities I'm presenting are for less than. Now, when it comes to another inequality, this one, what you call the greater than. Now, when it comes to greater than, now also you need to be very careful. Greater than, all these inequalities mean the same thing. Greater than means that is the sign that I'm going to use. So all these words, whenever you meet them, the sign you must use is greater than. When they say the height of the person was above 5, it means 5 and more than 5. More than 5. When someone says more than 5, above 5. When I say maybe when I say immaculate scored above 5 or above 10, It means that the marks she scored started from 6 and above, from 6, 7, 8, and 9. So that means you use greater than. When you meet the word exceeds, these are some of the common words they're going to be using. The word exceeds, the word more than, because they know that everyone can guess what greater than mean. So they try to twist and put some common, another word that may not be common. So when you meet the word exceeds, more than, longer than, larger than, above, these are the common. So the ones where I'm putting a star are very common to be used. Exceeds and above. So the moment you find it, know which sign you're going to say. Because they can say, maybe Apio scored above 50. So above 50 means she scored above 50. It means she might have scored a 60, a 70, 80, or 90. So that is the meaning. Immaculate is marks exceeds 80. It means she got something above 80. So she might have scored a 90 or 100. So you need to pay attention to those words. So those words, it means greater. The moment you find any of those words, it means you're going to use a greater than sign. Another one, these are the other words that they use. Now, the moment you find any of these words, greater than or equal to, greater than or equal to, which word is very common? The words where I put a star are very common. At least and a minimum. So when they say at least 80, it means that greater than or equal to 80. In case at times the teachers will tell us that make sure you score at least a 90 in my paper. So when they tell you that you must score at least 80, they mean that please, the minimum mark, the lowest mark you should get should be 80. So minimum, when I tell you that the minimum mark I wish for everyone online now is a 90 mark, it means that I don't want anyone to get or to score something below 90. I want you to have 90, 100, or 99 in that range of marks. So please pay attention. The word at least, the word minimum, they can easily be used. And all these words mean the same thing, greater than or equal to. So when it comes to those mathematical statements, those are the words they are going to use. And the moment you see it, now you need to know which word to use. Then the last group of words are these words. And all these words still, they mean the same thing, less than or equal to. So the common words being used is at most or maximum. They are going to be very common. So the moment you sit, know which word am I using? Which inequality sign am I applying? So when I say that the maximum mark is 100, the maximum mark, meaning when I say maximum, it means that that is the highest I can ever score. I cannot go beyond that. So when I say that the maximum score from maybe the maximum score is 100, it means you cannot get above 100. You will either get 100 or something below that. So please be very careful and let us master these words. The moment you master them, and I want you always to apply them in your real life. You know, you can tell them, you can tell yourself that the maximum mark, mark that maybe I want should be maybe something of that nature. But don't use max, because maximum should be 100. So, but for you to get an A, the max, so please be very careful. The word at most and the word maximum, these ones are going to be very common. But any of these words that are here can as well be used. Okay, so let me hope those words are very clear to everyone, because they are going to be very common when it comes to inequalities. And they are the ones that will determine whether you are passing the number or you are getting a low mark on that particular number. So kindly be very careful to know that this is the inequality that I'm going to use, and this is how I'm supposed to use it. Okay. So let me hope that is very fine on that. Then, okay, 2 participants. Okay, let me take on a question. Let me Okay, can I? Okay, I think I'm going to answer the questions in the chat. I think I'm going to how to easily find a in order and even situation. Go back to the previous slide for at least item number 2. Okay. I think okay. Let me first stop the sharing, and then I want to find out whether Our Lady, Saint Mark is ready. Saint Mark, kindly let me know whether you are ready. Saint Mark, I want to do one linear programming number, but Saint Mark, are you ready to take us through that number 17? Saint Mark? Okay, Saint Mark, kindly go on and share your screen. Okay, I'm going to be... Okay. Saint Mark, we are waiting now for you. Okay.
According to our triangle here, I think you can see the triangle. So when you place your compasses, you draw the circle inside the triangle. It will be the position where the sprinkler can be put in order to maximize the area. Also, part B says, part C says, estimate the area of the lawn that will not receive water which is effective once the sprinkler is optimally placed. Alright, so allow me to take you through part C. So, our part C, so to get the area of the lawn that will not receive water effectively, it is the area of the triangle with 18.75 is 4.330 centimeters. So now after getting our B, which is the same as our height, so now we can therefore get the area of the triangle using our formula, a half times base times height. So using our formula here, we end up getting the area of the triangle, which is 10.8253 centimeters squared. So now to get the area of the triangular line that will not receive water effectively, we shall get the area here, area of the triangle minus the area of the circle. So area of our triangle was 10. Centimeters squared minus the area of the circle, which was 6.1544 centimeters squared. So after subtracting, the area is now 4.670 centimeters squared. So now remember in our question, our units were in meters, so we have first calculated our area in 2 meters. So 2 meters are equivalent to 1 centimeter. Then what about the 4 meters squared? Also equivalent to 1 centimeter squared. So our area is 4.6079 centimeters squared, are equivalent to 4.6079 times the 4 meters squared. In brackets, we have our meter squared. So the answer is 18.6836 meters squared. So therefore the area of the lawn, that will not receive water effectively once the sprinkler is optimally placed is 18.6836 meters squared. So therefore you will be able to solve the question with ease. Thank you.
Okay. Thank you, Saint Mark. Saint Mark. Okay. Okay. Sorry about that. Okay. So, Saint Mark, I don't know whether now kindly let's open the number. Okay, they have dropped off. But when you look at the number then that Saint Mark has been doing, that number is the number concerning. That number is the number that is concerning loci. Like I told you, the idea you must have is that still that is number 2, where we talk about the loci. So St. Mark has demonstrated how you are supposed to do it. But what is the idea inside? The idea is you have seen many times when they are constructing roundabouts, or when you meet where there is a roundabout, the idea they use to construct a roundabout is the idea of what we are looking at now. So that's where that question is coming from, that the idea, when they are constructing a roundabout, when they are constructing roads, they always consider, or they put into consideration, the knowledge of triangles, they put into consideration the knowledge of loci. So it's somewhere where we can apply them. Now, when you look at the question, I want to just summarize They did so, but allow me to just throw more light. So here, the idea is they told that this diagram was not on scale, but when you look at these mark points here, it was demonstrating that this was a triangle. And the keywords that they use, that you as a student, like I told, the first thing you do, summarize what keyword is in the question, that there is a word equilateral triangle. Then you need to know that if it is an equilateral triangle, what do I know about it? That an equilateral triangle has all its sides that are equal. Now, after knowing that they are equal, then you are going to ask yourself, what about the angles? That also the angles are going to be equal. And then you ask yourself that what angles are going to be inside that kind of triangle that I have? That inside this triangle, in case all the angles are equal, it means I have x plus x plus x is equal to 180, which will give us 3x is equal to 180, meaning that the angle inside is going to be 60 degrees. So meaning that the angles inside are 60 degrees. Now, after knowing that, they told that each of these sides was measuring 10 and 10. So what they wanted you to find out is that explain whether or not you think all of the lawn in the triangle can be watered with a circular sprinkler. So you need to understand the question. So that was the idea behind it. So they were asking, if you know how a sprinkler works, those who are doing farming, when you are sprinkling water, it always makes something circular. It can make something like maybe circular, something like that. Like it can make something like a circular path. So just imagine it as B, and they were asking, where do you think it can be placed? So in case you are asking where it can be placed, it means that it will be placed at the center of your triangle, because it's going to make something circular, something like that. So it means that when you place it in the center, it means that it will be able to sprinkle here, here, and here. So that was the idea that was behind the question. But I wanted to just throw some more little light for those who did not pick where the question was coming from. So this is senior 1, when you are looking at geometry of senior 1, and then some bit of senior 4, but it has also been combined with areas and areas when it comes to senior 2. So it combines all those three topics. So the idea is you need now to know that you can have all the topics combined, but that is where the idea was. St. Mark is going to send us the solutions, and then you look at it and then you compare with what you had. So that was the idea. I was just giving you the idea. But still, let me emphasize, 1, when it comes to construction, kindly stick to graph paper. Use your graph paper. This UNEB graph papers are standard, and they are measuring that box you are seeing. Like when you have the box here, it is a standard graph that will be measuring 1 centimeter and 1 centimeter. So they are standard and they're uniform throughout the country. So it means that it will be uniform, everyone will get the same answer. So stick to the graph paper. But some of the rulers we have, they have lost some of the calibration units. Some of them are not so accurate. So that's why it is better you stick to the graph paper. So draw this on the graph paper such that you are very, very accurate when you are drawing it. So for these things that involve drawing the sketches and the rest of that, let us use graph papers, any number for construction. Still, go on and always indicate that this, in case this is your A, this is B, I'm just imagining. Then put clear that these are 10 centimeters, these are 10 centimeters, and these are 10 centimeters. And now for this particular one, even since they mentioned that it's an equilateral triangle, show that it's an equilateral triangle by putting the arrows, because these arrows are the ones that show us that all the sides are equal. So for construction purposes, things like bearings, things like constructing, inscribing, circumscribing, please stick to your graph paper. Do not draw in the question paper, because at times you may even fail to draw the straight line very well. So you find that you have drawn a line, but your line is a bit diagonal. So here you will not get the accurate answer. Yet when you stick to the graph paper, you can be able to trace out that bold line in the graph paper. But still, when you use it, never forget to write your index. Never forget to write your details onto the graph paper, because it can easily pluck out. And if you did not write your details, it means that you may not end up missing out on the marks. But St. Mark has shared something with it, but also I want now to ask other schools to kindly go on and complete it, and then you can share with us. But St. Mark will share with us their final answers. Okay, they have shared the final answers, but they will share with us the write-up such that we can follow it up. Okay, then the number that I wanted to throw more light, one of the last numbers that we have not done or we have not tried out is the number concerning linear programming. I want to just check out one number. Okay, let me use this number 6. Now, like when you look at number 6, this number has two things. It has the goods A and goods B, which are being produced. So they're telling you that this manufacturer, like I told you, imagine this is the question. So when you are reading, I'm going to first read it the first time. I told you when you are reading scenarios, read it more than twice, such that you understand. A manufacturer considers that men and women workers are equally efficient, and so he pays them the same rate. Then, when you are reading the second time, go back and start highlighting the key things, that he has 30 units of male workers, 17 units of female workers, and capital respectively, which he uses to produce 2 types of goods. So he produces type A and type B. To produce 1 unit of A, 2 workers and 3 units of capital are required, while 3 workers and 1 unit of capital are required to produce 1 unit of B. Goods A and B are priced at 100,000 and 120,000 respectively. Now, what is the first thing you are going to say? We say that whenever you read your question, highlight those key things that you are going to need. Anything you highlight, it means that it's going to be helping you during the calculation. Now, what about what other information? Then read through the question first. See what does the question want, that they want you to maximize. They want you to give your conclusion, meaning that you must factor it in your head. Okay, then what else are you going to do? Now you are going to summarize your table. Now, in your table, when you are summarizing, you have 2 things. One, you have what you call the workers. And after the workers, what else do you have? I have things of capital. Now, what do I need to know? I'm going to draw my table. In my table, I'm going to ask myself, and what are you producing? I'm producing good A and good B. So you're going to ask yourself that when it comes to workers, they have told you that he has 30 units of male workers and 17 units of female workers and capital respectively, which he uses to produce 2 types of goods, A and B. To produce 1 unit of A, 2 workers are needed. So A, here I'll put 2, that those are workers under A. 3 units of capital are required. Still under A, I'll put that 3 units are required. Then I continue. While 3 workers and 1 unit of capital are required to produce 1 unit of B. Then I go back that when it comes to B, he needs 3 workers and 1 unit of capital. Now I ask myself, now what do I need to know? That he has 30 units of male workers and 17 units of female workers and capital respectively. So meaning that when it comes to 17 units of female workers and capital respectively, so meaning that here I'm going to have my 17. Then when it comes to the workers for A, let me do it like this. The workers here, the total, I'll have the 30. Then for the capital, I'll have the 17. Now, when I'm extracting my constraints, I'm extracting the constraints I'm going to use, that this is just the table to summarize. But remember, we have not yet finished. So I define, we say the next thing you do, define that let X denote the units of good A. Maybe that is okay, of good A. Let Y denote this and this. such that you know what you are going to use, that which things are varying, that I'm looking at producing good A and good B. So after that, so now this is, let me say B. Now you're going to come and say that what are my constraints that I'm going to have when I'm looking at the workers' constraints? I'm going to have when I'm looking at the capital constraints. Now I'm going to say I'll have 2x, since I've said that A stands for the X, I'll have 2x plus 3y. Then they told that this gentleman has 30 units, meaning that is what he has. It cannot go beyond that. That is the maximum he has. So here the word he has, it means that they are very sure it's the maximum number. So which inequality do we use? It is less than or equal to is what we use. So I will say less than or equal to 30. And 17 units of female workers and capital respectively. So meaning that here I'm also very sure that capital, it will be 3x plus y less or equal to 17. Because he's sure that that's what you have. I'm very sure that the maximum mark you can get is 100. Whenever you enter the paper, what I know you can get is 100. So it is you who goes on reducing your mark that you want to score in the paper. So these are the two major inequalities. Then I'm going to go on and say what is other inequalities. Now, after writing all your major inequalities, please don't forget to write what we call the non-negative constraints, and then say that I cannot have, I will have x greater than 0 and y greater or equal to 0. Just write them and have them there. Then the last thing that I can include can be since this is what relates A and B, then I can say those are my mathematical statements. So then I'm going to ask you that when you go back, at least since we have all the inequalities, then you can go back and draw and see which region you come up with. But now do not forget, since you have said that X denotes good A, I expect you that on your graph where there is X, here you put good A. This side you put maybe good B, because those are what you want. Good A, good B. And then label that this is Y axis, this is X axis. And whenever you meet that, maybe you find for questions where you are using greater than, less than, and you find you have a dotted line, please never extract any answer from those dotted points, because they are not part of the solution. So whenever you find that you are meeting decimal, you are using a dotted line for your feasible region, for that particular line, don't extract your point. And always the first points you check out for the corners, for the polygon that you are forming, and check out for those sharp points. They are the ones that usually can give you the maximum or the minimum, but also test other values. At least for the values that you are testing to obtain your minimum and maximum, make sure you have at least 5. Use at least 5 values to test for your maximum or the minimum. And now for this particular question, since you want to maximize the revenue, it means that still you are going to say, let the total revenue be maybe R. Therefore, you can go on and say now my R is going to be 100,000 that I obtain from A plus the 120,000 I obtain from the Y. Then afterwards, you'll go on and draw your table. Still in your table, specify that this is my revenue. These are like my constraints that I'm getting, and this is my revenue. And then fill in the coordinates. And when you're writing in your table, sure that they are coordinates. Don't forget to put your brackets. And then after you do your number, and then you can make your conclusion at the end of the day. So, but what I wanted is to show you how to summarize. At times they may not use the words you expect, but when they are very sure. So whenever they are very sure, please think that that is a maximum and you cannot go beyond that. Okay. Let me hope. Okay. Yes, Alwa. Yes. There is some. He has 13 of male workers. Yes, that is very true. And female workers. So there's it was supposed to be something like this. he has 30 units of male workers and female workers, and 17 and 17 units of capital. So it was just a typing error, and 17 units of capital. So that's how the question was supposed to be. Okay, but that is the idea on how you do it. So please, you go on and you complete it, and then you can show your teachers what you have come up with. So I expect you to come up with your graph, a good graph, and after you can show your teachers such that they can be able to mark you. But do not shade anyhow. Okay. I think I'm going to end here on this number. Then the rest, kindly you handle with your teachers. Then I want to ask St. Andrew Gombe. St. Andrew. Oh, okay. Let me take one question. Queen of Peace High School and CBC Question Bank Group.
Yeah. Yes, good evening, sir.
Yes,
your
good
program,
evening.
you have not mentioned about using the intercepts while finding the coordinates. Can you use these intercepts to find the coordinates?
Okay. Yes, it is very okay. You can use the intercepts. But now I want you to be very careful when you're using the intercepts, that there are questions where you don't, where your intercept may not work for you. So for such questions where your intercept does not work for you, then you need to know that you are going to continue. Take an example. At times, let me say, there is a time whereby when you use the intercept, you find yourself getting very many decimal points. So you are getting a decimal point. Take an example when you have x plus, let me say 3x plus y may be greater than maybe 7. You find that this is 3x plus y is equal to 7. So you can use your intercept that this is my x and this is my y. And then you say this is when x is 0, my y will be 7. In other words, what you do is say 3x plus y is equal to 7. So meaning that where there is x, I will put 0. So 3 times 0 plus y is equal to 7. So I get y is equal to 7. Then when y is 0, I'll get now my x is equal to 7 out of 3. So you notice that when you have 7 out of 3, this one may be a bit tricky for you to plot it. So meaning that for such a case, increase and have other values at least such that you are very sure of your line. Otherwise, 7 out of 3 may be very tricky for you to plot and you may not be accurate. So for such a case, because 7 out of 3 is 2.3333, so you may not be very accurate to locate it. But yet, when you increase on the values, let me say you increase on the values of x, maybe use another value, you may find yourself that you can get an exact point that is easy for you to plot. So for cases where you have points, then please increase on the value, use other values such that you can be able to draw a good straight line, such that you are very sure that my line must pass through here. And after drawing the table, never forget to come and summarize that my coordinates are this, my coordinates are this. But for these fractions, at least write to one decimal place in case you are plotting the coordinate, and you round upwards. But you need to be very careful still when you are attempting, such that at least avoid having points, at least increase on the number. Even if you are plotting this line, I've seen very many students finding challenge. They find something, y is greater than 2. Now, for such a case, in case you don't know actually how this line looks like, it means when you change it into an equation, it becomes y is equal to 2. So once you meet such a line as a student and you actually don't know how to draw it, then you say this is x and this is y. So this one means that your y is 2. Y does not change at all. So meaning whenever there is y, I put 2, 2, 2, 2, 2, whenever there is y. So I go to x. What is my x? X, I can put any values. I can say 0, 1, 2, 3. So that means that I will plot my coordinates 0, 2, 1, 2, 2, 2, and 3, 2. Similarly, when it comes to maybe x is less than or equal to 3, This one means that x is equal to 3 when you form your equation. So in case you don't know how that line looks like, in case you get confused, because at times we are very anxious in the papers, also please do the same, that x is equal to 3. So whenever there is x is 3, x is 3, x is 3, x is 3, it does not change. So meaning it is only y that changes. So y, give it any value of your choice, 0, 1, 2, 3, 4, and the rest of that. And then see how those lines come up. Okay, I think I have answered you on that. But for values, like I've said, for points, please include more values to be very safe. Okay, let me hope that question has been asked. I wanted to find out St. Andrew. St. Andrew says something. I want to find out. Okay, okay. St. Andrew Gombe, kindly unmute.
Okay.
Okay, okay. St. Andrew, you may ask the children to be a bit quiet, and then you go on. St. Andrew?
Yes, good afternoon, visionaries. My name is Vulundi Patience from St. Andrew Kampala Gombe High School, Bujuko Campus, Senior 4. I'm here to present data and probability item 10. And it goes, a certain company in Kampala is analyzing the optimal departure time for its 40 employees to ensure they reach home by 6 p.m., minimizing their commute to home, their commute time, and avoiding peak traffic congestion. The company conducts a survey to track the times employees typically arrive home after work, measured in minutes past 5. Some of the keywords in this travel regularly by bus, train, or car.
Sorry, St. Andrew has some network issue. Okay, but as St. Andrew comes back, when they come back, I'll go off. Let me first answer this question. Someone is asking, what if you get, okay. So that is the question St. Andrew was trying to read for us. I think it is now appearing on your screen. That is the question that St. Andrew is trying to answer. Okay, now when you look at that is the question, they are coming back on board. But one thing someone in the chat was asking. Okay, so St. Andrew, just a minute. Someone was asking, what if I'm given 2x, I think 2x greater than y? How do I approach such? Now still, I'll first let you know that first form your equation, that 2x is equal to y. Now, this one, let me draw here. Okay, I can draw here. So still formulate your simple table. There is no problem. Say this is my x and y. Now for such, here you cannot use the intercept form. The reason is that whenever you say that x is 0, it means you are going to say 2 times 0 is equal to y. meaning that 0 is equal to y. So y is also going to be 0. So when you say y is 0, it's also 0. So for such, whenever you find that you don't have an intercept, please don't use that intercept form. So what do you do? For this, generate the values of x. Say, let x be 0, 1, 2, 3, 4, and the rest of that. Then come back in here in your equation, which is y is equal to 2x. Where there is x, put the value that now it is 1. So I will say is equal to 2 times 1, which is equal to 2. So here I will put 2. When x is equal to 2, then you say 2 times 2, which is 4. Put here 4. When x is 3, put 2 times 3, which is 6. And then at the end of the day, extract 0, 0, 1, 2, 2, 4, and then plot that line. But please, another thing I think I need to emphasize, do not forget to go on and label your lines. After drawing your lines, label it that this is the line, y is equal to 2x. And after labeling, label it that this is the line. Do not use inequalities that y greater than 2x. No. And now for this one, it is dotted. So I expect to be a line of this nature, but it is dotted. Okay. St. Andrew, I think this is the question St. Andrew they have been reading to us. Those who don't have the question, that is the question that St. Andrew is working on. Okay, St. Andrew, we can go on. But I think you have told me it is disabled. Okay, St. Andrew, go on.
Okay. The first task goes, based on calculations using the collected data, suggest an optimal departure time for employees to begin their commute home. As I told you earlier before, that commute means traveling regularly by bus, train, or car from your workplace to your home. So, telling us to find that the optimal departure time, we need a frequency distribution table. And as we all know, a frequency distribution table, we need a title for it. And our title is a frequency distribution table for the arrival time in minutes of employees of a certain company in Kampala. So the first row, which we call the classes, first we are naming each minute because we are dealing with minutes, not classes. So the second one will be the tally frequency, mid-mark, class boundaries, and then lastly the class. So we are going to start with 10 to 19, 20 to 29, 30 to 39, 40 to 49, and so on. So we are going to first tally them because we can't find the frequency of something before tallying it. So 10 to 19 was 1, that is the tally, and the frequency is also 1. 20 to 29, which was 5. In tallying, we don't like put all of them at the same point, but we are unable to do how the tallies are made. So we found that option for you guys. I hope you understand it. So 30 to 39, which was 8, and the frequency is 8. 40 to 49, which is 6, the frequency is also 6. 50 to 59, 6, the frequency is 6. 60 to 69, frequency 6, and the tally is also 6. 70 to 79, tally 6, frequency 6. 80 to 89, tally 2, frequency 2. And then you have to find the summation of F, which is 40. Then we move on to the mid-mark. The mid-mark is found by adding the lower class plus the upper class. You first of all find the total of them before dividing them by 2. We get 10 plus 19. We get the answer, which is 29, and we divide it by 2, getting 14.5. Then 20 plus 29, we do it like that we have did the first one. So we move on to fx. We find fx by multiplying the frequency by the mid-mark, which is the first one, 10 to 19, is giving us 14.5. The second one, 20 to 29, is giving us 122.5. Then we move on to the cumulative frequency. The cumulative frequency is formed by adding the frequencies. but the first one stands, when the first frequency is 1, it stands as 1. And when we move on, 1 plus 5, 5 plus 8, and so on. 1 stays as 1. 1 plus 5, 6. 6 plus 8, 14. And then we add up to the last one, giving us a total of 40. And in this cumulative frequency, you have to be aware of this. The last digit must be equivalent to the summation of F. Are you getting me? Then you move on to the class boundaries. We get the class boundaries. The lower class, we subtract 0.5 when we are having whole numbers. But then when we are having decimals, we subtract 0.05. But in this case, we are dealing with whole numbers. We have to subtract 0.5. And then the upper class, we are instead adding, not subtracting. We are also adding 0.5 because we are having whole numbers. You do that throughout till the last one, which is 80 to 89. And then our class interval was at 10 throughout. That was it for our frequency distribution table. And then you were told to find the optimal departure time for the employees to begin their commute home. So, as I told you, the commute home is that time these workers will leave their place work to their homes. So this departure time can be called the average or the mean time. And then the average, it's like something that favors most of the, like we are dealing with the minutes. We have to find something that favors most of the employees, that time that favors most of them. So our average is got by the summation of fx, and you divide it by the summation of f, which is, remember our summation of fx was 2010. So we are going to divide 2010 by 40, which will be giving us 50.25. We could say this like 50 minutes and 25 seconds. But since these are minutes, we can round them off and we have 50 minutes. So remember in the question, they had told us that the company conducts a survey to track the times employees typically arrive home after work, which was measured in minutes past 5. So we are looking for the time that these workers may leave the workplace past 5. So we are going to get the 5 p.m. and we add the 50 minutes that we have got. So the optimal departure time for the employees to begin their commute home will be 5:50 p.m. Then task B, following are devised to allow employees to leave work when at least 50%, please note that 50% down, of them have already arrived home. Determine the optimal departure time. As we are dealing with the frequency distribution table like questions, we have certain things that we have to note down. We have things like quartiles. Let me assume that all of you have heard about them and studied about them. We have quartiles. We have the lower quartile, which is 1/4. We have the middle quartile, which is 2/4, and then the upper quartile. So guys, when we have been given 50% of the employees who have already arrived home, now we are dealing with the middle quartile. Because remember, 50%, the percent gives us 100, which is 50 over 100. When you get 50 and you divide it by 100, that is giving us a half, meaning that this 50%, they're asking for the median. As we all know that median is something in the middle. So 50 is in the middle of 100. And then now we are dealing with the 50%. So the 50%, we're not going to use the other method of the quartiles because the 50th percentile is the same as the median. So we are going to find the median. I hope you're following. Yes. So the median equals the lower class boundary of the median plus, open the brackets, summation of f divided by 2 minus the cumulative frequency before the mean divided by the frequency of the mean, and then you close the brackets, the class interval. So when you divide 50, when you get the 40, which was the summation of f, you divide it by 2, you will be getting 20. Remember, in our frequency distribution table, we go to the column of the cumulative frequency, you look for the 20 and where it falls. So 20 will be falling in the column of 40 to 49, and the lower class boundary will be 39.5. So our lower class boundary is 39.5 plus 40 divided by 2 minus 14 divided by 6, close the brackets, times the 10, which is our class interval. So we shall have 39.5 plus the 1. This one has been got by doing this. 40 divided by 2 will be giving us 20. 20 minus 14 will be giving us 6. 6 divided by 6 will be giving us 1. Remember, this one was in the brackets. The answer we have got by subtracting and dividing the 40 by 2 minus the 14 by the 6, which was giving us 1. This one has to stay in the brackets times the 10. So we shall have, remember, when you multiply 1 by 10, we shall have automatically 10. So we shall say 39.5 plus the 10, which will be giving us 49.5. And then when we round them off, we shall have 50 minutes. So the departure time will be the other 5 p.m. plus the 50 minutes, giving us 5:50 p.m. Therefore, the optimal departure time, when 50%, remember they are told us to find the optimal departure time when at least 50% of the employees have already arrived home. So the optimal departure time when 50% of the employees have already arrived home is 5, I'm sorry, it was a slip of a tongue. It will be 5:50 p.m. Thank you. Let me proceed with task C. As the company management, which of the two suggested departure times from A and B would you choose to ensure employees reach home by 7 p.m. and why? Okay, let me read it again for you guys. As the company management, which of the two suggested departure times from A and B would you choose to ensure employees reach home by 7 p.m. and why? So if you've been following, you've noticed that in part A, we got our departure time as 5:50. And also in part B, we got our departure time as 5:50 p.m. So as the company, for the question, as the company manager, I would choose both times as the departure times for the employees, simply because both the times will be, all the times, most of the employees would be home. And so the chances of the other ones who will not have already arrived at their homes will not face so many challenges of traffic congestion. So I would choose that. Is there any questions for me?
Yes. Let me ask. I'm the one to ask first. One, on 8 and 90, which one would you choose?
Pardon?
On 8 and 90, if they may ask you, on 8 and 90%, which one would you choose?
I would choose 90%.
Why?
I would choose 90% because most of the employees would be at their homes. And then with the 80%, some of them will be home and some will be out. But then with the 90%, most of them will be at their homes, and then the chances of facing traffic congestion favoring the company and the employee. And then be home, and then the chances of the others who are still home, who are still at work, the chances of them facing traffic congestions and some other problems will be at 20%. So therefore, I stand by 90%.
Okay, I wanted to I want you to answer in terms of marks. Just imagine both of them are giving you an A in math. When you get 80 and 90, but when they ask you choose, so which one would you go for? Do you say both or you take on one? Okay, because I wanted to look at the conclusion mainly. I wanted you to look at the conclusion because they asked you to choose. Okay. St. Andrew. Yes, because there were two suggestions that were put on the table. So you need to, you needed to make a conclusion. Which one would you take and why? So your input, you had said you wanted to take both. Yet they wanted you to select one because they told you to make a choice. So can you make an improvement in the conclusion and we see?
Okay, so let me answer you. I chose both of them, but since I chose both of them, yet they had asked me to choose only one, simply because both that are enabling the employees and the company as well.
Okay. So, okay, for the first choice, okay, can you tell us that for the first choice, at what time will they reach home?
For the first one, they'll be reaching home at 5:50 p.m.
Okay, then the second option?
Also 5:50 p.m.
Okay, okay, okay. Yes, but I think why you got 5:50 for both, you rounded off somewhere.
Yes.
Yes, so that's why you were able to get the same time because of the golf.
Okay, excuse me, sir. Just something small. I told you in the second one that I got, no, in the first one, I got 50.25. And I told you this can be read as 50 minutes and 25 seconds. But then I rounded them off and I stayed with 50 minutes. That is it. Yes.
Okay, yes. Now, I think we need to still emphasize that when it comes to time, those seconds can count.
Yes.
Those seconds count. And we say that always make sure, avoid, we call it premature approximation. Avoid approximating to the final answer before you have made a conclusion. So those 20, if 550 and 5, let me say 550 and some seconds, it means that one of the people will arrive at least a bit more, a bit 25 minutes into something. So you needed to, before you make a conclusion, before you round off to 0, always first wait. And for the time, I think I say that avoid rounding off to, avoid what you call premature approximation, mainly for those questions that may ask for your input. Yes, for those questions that may ask your input, but the working was very okay. But I want you to share your screen again as we take on some questions from Queen Peace. Ediofe girls, you can ask. Share your screen again. Clencio and Queen of Peace, you can ask.
Oh, thank you, Mr. Kazuwa. Actually, mine has
for the presentation, but I'm asking that if
Yes.
in the question it was not 50% and it was like 20% or 10%, now what could we do?
Yes. What could you do? Like as in finding the time?
Yes.
Okay. Okay, first part on your question. Excuse me, Queen of Peace. Repeat your question for me.
They're asking, what if it was 10% instead of 50%?
Yes. What if it was 20%, not 50%?
Yes.
What could they do?
Okay.
I think they
Mr.
could
Kazuwa, can I
calculate.
answer on her half?
Okay, it is fine.
When you are asked of any percentage like 10, we first look for the position where that percentage is lying. If it is like the 10%, that is 10 over 100 times the CF, okay, times the CF, such that we get the position where that 10% is lying. Then we use the formula, L like the formula of median, but on the summation of F over N. There we put there 10 over 100 times the summation of F. Like the how you are looking for quartiles, which is 1 over 4, okay? Like the lower quartile, like the upper quartile, which is 3 over 4. You also look for the position where that quartile is lying. The same applies to 50%. She also looked for the position, although it was in the median, okay? So if it is any other percentage, you also look for its position, then you substitute in those values in the formula, as simple as that one.
Okay, thank you so much, Teacher Clancy. Yes, Teacher Clancy, your hand is still up. Okay. St. Mary's Ediofe, I think I'm going to throw some light. Yes, Ediofe. Yes. St. Andrew, take me to your table. That's why I want to start commenting. St. Mary's Ediofe, yes. Ediofe, ask. St. Andrew has dropped off. Ediofe, you can ask. Oh. Okay. I think I'm failing to get full. But St. Mary's Ediofe, ask, go on. Okay, St. Andrew, you are taking me back to your table. Okay. Okay. I think I've failed to get St. Mary's, Edofe, Selele Town, Selele Unmute.
When doing parties,
yes, Selele.
When doing parties, they say to set the optimal time when 50% had already arrived. Meaning, they are going to set the time when 50% had already arrived.
Okay. I've not picked the question very well. Very well. I've not picked. Yes.
Saya just had number. Sahela pass to the number. Sahela pass to the number.
We were not the ones to be.
Mute. Okay, let me mute everyone. Now I'm commenting one. St. Andrew, I'll kindly request you that in the table, let's always avoid putting irrelevant. Okay, now like where you are seeing constant values that do not change are always better that we just state them. Like you say class interval is equal to 10. So there is no need for us to put them onto our table because we may not use it. But for values that do not change, always it is advisable that we do not include them onto our table. But I'm really very happy, like you have mentioned it, that you have minutes. Yesterday I emphasized it and I want to emphasize it again, that always let's stick to what the question says. In case there are minutes, put the minutes. There is no need for you to go on and put, let me say, you put a class. Instead of putting classes, put the minutes. The same thing will happen when you go to your curve. Instead of you putting just class boundary, put what you are doing, that these are minutes, these are number of people. That is the good mathematics you can write. But also I want everyone now to look at the coherence, how their work is flowing. From minutes, they went to tallying. From tallying, they went to frequency. From frequency, they went on and went to the mid-mark. They went to f of x, they went to cumulative frequency, and then they went to class boundary. So we say that in the table, only include things you are going to use. And when you actually look at their table, everything they have mentioned, they have used it very well. So that was really very nice, St. Andrews. So the rest, let's copy the good practice on what we are supposed to do. Then I want to comment again on what we call the percentage. I told you that whenever you meet a percentage, whenever you meet things that require you to estimate, maybe they have given you a percentage, they have given you they have told you find the number of people that are above 50, the number of people that are below 50, the number of this and the rest of that. Kindly always know that you have to, for estimating when they are not percentage, that find the number of people who do this and this, who are above 50 and the rest of that. Those ones bring in what you call an ogive. So for this particular number, you had two options you could use. One of them could be the ogive. And for ogive is mainly used for when you are making the estimations. So for this particular number, you could either calculate using the central tendency of median, or you could as well go on and use the ogive. So both of the approaches could lead you to the answer. So both approaches were okay. So someone who used the ogive, it was very fine. Those who know how to use the formula, it was also very fine. But when they tell you calculate, now let me say, in case that question was specific and they wanted you to calculate the 50%, calculate when the 50%. When they say calculate, it means that they want you to use the calculation method. They want you to use the median formula, or they want you to use the what? The formula. When you see that estimate, then that one is okay. You can estimate using the best approach to do the estimation is using the ogive. So always look at what are they asking. Do they want you to calculate? Do they want you to do the estimation such that you know what you are going to base on to do? But I told you, when you meet percentages, in most cases, when it is about percentage, it is about estimating. What has to come into your mind is what we call the ogive. It will be very, very crucial to know that. And then I told you at times when it is not about percentage, even they can ask you when it requires to draw a histogram, when it requires you to do the rest of that. But that one I will ask you to review yesterday, or I will share with you that PowerPoint such that you really know what you have to do. Then when you are looking at the table, St. Andrew, I don't know, I want you to put back on your table. Again, there is something I may need now to throw more light. When you are looking at things you are going to use, if you have not, I want you, okay, the table. Okay, take us back to the table. Okay, they are taking us back to the table. There is something I want to emphasize on the table. Table. St. Andrew, the first slide where you have the table is where this the one I want. Oh, okay, I don't know. They're still, okay, they're taking us back. But I want you to, when you are going to put frequency on your table, kindly put frequency, then in brackets you put F. Okay, give me a minute. So I was emphasizing that when it comes to the table, like the way you saw how they did it. So I want you always have your table. In case like we have said minutes, you put the minutes. In fact, if they have even put the units that it were, let me say it was, okay, now like maybe it was time and it was minutes, you can set time in minutes. Now, in case you are going to put the tally, put the word, don't just set T. Go on, put the frequency. Now, frequency, write the word frequency, and then in brackets, put F. Then go to the next one that I'm going to look at the mid mark or mid mark. So say mid mark, in brackets, put X. Then after that you have defined what F is, what X is, then that's when you can go on and write your F of X. That's when you can go on and write maybe your cumulative frequency, the class boundary. So for some of those things, please make sure that we don't just write F. F can stand for something else. Don't just write X. X can stand for something else. So be specific that frequency, put F. So someone marking will know that where there is F means frequency. Where there is X, it means mid-mark. Now, like I've said, or like how teacher Crencio specified that when it comes to this median, the general formula is given by the lower class boundary plus some schools you can use summation of F out of 2 minus the cumulative frequency before out of the frequency of the median class, then times the class interval. That is the formula. Now, the key thing you need to remember is this. So for any percentage they give you, this is what changes. That when I have summation of F out of 2, how did it come about? When we call them the quartiles, that we have mainly the 3 quartiles. We have what we call the lower quartile, we have what we call the upper quartile, and we have what we call the middle quartile. So lower quartile occupies 25%. The middle one occupies the 50%, and this one occupies the 75%. So 50% means 50 out of 100 of the total of everything. 25% means 25 out of 100 of the total frequency. Then upper means 75% out of 100 of the summation of F. Now, for this median, the middle one, the one we call the median, for it, when you reduce, you say 0, 0, by 5, 1, by 5, 2. So you have summation of F out of 2. So that's why for it, we write summation of F out of 2 in the formula. But in case it is maybe 80%, they have told you 80%, then say 80 out of 100. Feel free to reduce 0, 0. Then you can go on and say, in case you want, there's no problem. By 2, this will be 4. By 2, this is 5. So meaning that when you come here to substitute, your formula will become L plus, now here you come and say 4 out of 5 summation of F minus cumulative frequency before out of frequency of the median class, then times C. But the most important thing is to find out the position using this. So that what you call the position. So to find out that position, first say 4 out of 5 times summation of F. Let me say it is 40. Just I'm using it as an example. Then go on and say 4 divided by 5 times my 40, I'll end up with 32. Then go to your table where you have drawn your table under the cumulative frequency. Look at where 32 is or where 32 lies, and then highlight everything within, and then use everything within that column, within that row, the same way we use it when you are finding the median. Whatever percentage they tell you, for you just substitute here. Even feel free to say, my formula, instead of 80, put here 80 out of 100. In case they give you 40%, say L plus 40 out of 100, summation of F minus cumulative frequency before out of frequency of the median class times the class interval. But to get the lower class, to get cumulative frequency before, to get the frequency of the median class, first find out the position using that percentage they have given you. Now, in case you don't want to use that approach, then go on and use what you call the ogive, or what you call the cumulative frequency curve. Draw your curve very well. Say that this is my curve. And on my curve, what do I have? That I have my class boundary. Now, this class boundary, even be specific, what do they represent? That they are representing my time. What do I have here? I have my cumulative what? Cumulative frequency. And even you can be specific. What does the cumulative frequency represent? That it represents the number of people. Then draw your curve very well, that this is my curve. Now, after drawing your curve, come and tell us that I had, maybe they wanted us to get maybe 80%. So I'll come and I say 80 out of 100 times the total number of people. Maybe they were about 50. So you reduce by 5, 1, by 5, 2, then you get 40. So here you get the 40. Then come, read off where the 40 is. So come check out where is the, when 80% of, check that these are the 40 people. You draw your line, we use dotted lines, come mark down here, and then read off which value you have at this point. So it indicates the time. But please do not cram. At times they will tell you that estimate how many people had arrived at maybe 8:55, something like that. Then it means that here you are going to read off your value using the x-axis where your time is. So come here, draw your line, and then come and then read off what you have. So this one mainly comes when they ask you how many people were above this, how many people scored below this. So now you need to know. Now when they ask you for above, it means they want this number that was above. So after, let me say this was 20 and your highest number was maybe 35. Then to get the number of people squared above, then you say 35, the highest number, minus 20. In case they want those people squared below, then you take the 20 the way it is, because all those people were below. So that is what I wanted to emphasize when it comes to this. So please take note of now on how we are supposed. Even don't forget to write the title on your graph, that an ogive showing the time and the number of people. The ogive showing this and this, or a graph showing the time and this, such that someone marking you may be able to follow up your work. Okay, I'm seeing a hand up. Yes, Joel Mukwaya. Joel, unmute. Okay. Okay. Joel is fading. Let me get add. Okay, Celery Town, unmute.
Sir, does it mean that their values are correct?
The values of?
For B and C, are they correct?
Okay. What do you have?
They said 550 and 550.
Okay, what do you have, you? The ones you calculated?
We say the optimal time would be the mode. And that is the time many people would have arrived.
Okay, we are going to go back to the question. Don't worry, we are going to go back to the question. But one thing you need to know is that the mode, the median, mode, median, and then the mode, median, and the mean. We call them the central tendencies. So they will always give you answers very close to each other. So they will always give you answers close to each other. So they will be very close to each other. But I think we are going to go back. I've not gone through the question clearly. But in case they wanted when many of them are alive, the optimal number, then that one is actually the mode. They asking the time when many of them had alive. So that one we base it on the mode. But what you have to know that those three major central tendencies, they will always give you the answers within the same range. Admin? Admin? Okay. Okay. Let me ask St. Andrew, can you conclude? St. Andrew, can you conclude? Okay. St. Andrew, conclude. Yes, Joshua, that would be very okay when you use, say, mid-minutes. Yeah, in case they are minutes. Then for frequency, we can use that small f. For cumulative frequency, because now some of those letters we are using are not mathematically or are not widely used. So you may only be the only person knowing it. So for such things like when you find yourself using CF for cumulative frequency, write down the table that CF means cumulative frequency or stands for cumulative frequency. Put it down the table for any abbreviation that you go on and use. Yes, because I've told you we must maximize and we must always look out for that excellent mark. Okay. Admin, I'm trying to unmute you, but I'm failing to get you. Okay, admin, ask. Admin, ask. Okay, I think I'm failing. Now, okay, admin. St. Andrew, do you want to conclude? St. Andrew? Okay, I think, yes. Okay, Queen of Peace, ask.
Thank you, sir. For the case of the median, what if we find that our lower class boundary is in between of the boxes of our graph?
Okay. Okay, now, let me say, this is maybe, let me say, okay, let me give you an example. A case in point when you have your class boundary, and let me say, this is 44.5, and this is 49.5, something like that. Now, when you look at this, in order for you to know, let me say you have jumped 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Those are the boxes. You have jumped 10 small boxes. So in order for you, in case you have drawn your thing, you have finished to draw, and you find that your thing is maybe somewhere here. That's where your line is lying. What are you going to do? One, first find out what does each of these small box here contain, this small one. So what are you going to do? To find out what it contains, always get the two values in between. Say 49.5 minus 44.5. Divide by how many boxes are in between, that there are 10 small boxes. So I'll say 49.5 minus 44.5 gives me 5. Divide by 10, which is 0.5. Meaning that the boxes here, each box you are seeing has 0.5. So what do? To read off this value, I will start from 44.5. So I will say 44.5 plus, then I count from 44.5 to where I've stopped. How many boxes are there? That 1, 2, 3, 4, 5, 6, 7. Then I will say 7 boxes times what each box contains, which is 0.5. So then I will say 44.5 plus 7 times 0.5, which is 3.5. Then I will come and I say 44.5 plus 3.5, and I will end up getting 48. In case there are minutes, you put even the units, that these are minutes. So that's how you read it off. Hope it is okay, the person who asked. Okay. Okay. I think unless there is another question, and okay, in case you have a question, feel free now to ask. Let's use this time now to ask. Someone was asking about which question? Someone saying they're not. You are not seeing my working? Oh, kindly let me know. Isn't my screen on? Hope my screen is on. Okay. Elusi Nebi?
Yeah, thank you, Mr. Kaziba. Your screen is on, although the other school had shared their screen also. I think it was hearing, but the question I'm receiving here is that as at times that access of the class boundaries, some because now it may, like this one is starting from 44.5. Now some think that maybe wants to start is also from maybe from 0, but then because it cannot reach 0, so they use like some broken line, some zigzag, something like that. Yeah, I wanted to share it also. Yeah, you're even doing it. Something like that.
Okay. When you're doing what? Mode or any?
Or
Okay, any.
Even this one, yeah. Even the okay. Something like that.
Okay.
Thank you.
Now, okay. Okay, now, when it comes to this graph, my advice would be more so when you are dealing with cumulative frequency curve, because when we are plotting the class boundary, let me be specific that this is my class boundary, 49.5 to 54.5, 54.5 to 59.5, then 59.5 to 64.5. Now, please take note. Now, in case you are drawing this kind of graph, and you are drawing maybe class boundary, if you, let me say this is our axis, please, when you do like this, let me say 54.5, you go to 59.5 because you're using the upper class boundary. This one will be totally wrong. Why? Because here, this value is not 0. There is a value that comes before 54.5, which is 49.5. So this one is not right. So you cannot say that since I'm taking on the upper class boundary, I'll start from 0, unless you put this. So when you put like this, that is very okay. However, I'm going to advise that when you are getting the class boundary, always feel free to start from the lower class, which is 49.5. So here, start from 49.5, go to 54.5, go to 59.5. What happens is that this class boundary, the meaning of this is that for 49.5, there is a class here up to the class before it. Its frequency is 0. That is the meaning. So you putting it here, it means that the frequency for 49.5 is 0. So when your curve comes like this, it is very fine. But in case you start from 54.5, it means that you have not shown that 49.5 has a frequency of 0. But this one is not penalized. It is very fine also. It is very fine. But the best one, or what I want to say, that for frequency curve, I would always advise that let us start from the lowest class, which is 49.5, and then you move on to the upper other classes, that 54.5, 59.5, 64.5. Instead of you starting directly from 54.5, and also you make it worse by putting here 0, then you go to 54.5. Even if you go to 49.5, unless you put this to show that there are very many other values that are coming. But in some cases, candidates usually forget to put that continue with, because that one shows us that from 0 up to where you have started from, there are other numbers in between. So when you forget this, someone has the mandate to mark you wrong. The same thing happens in case you are using in case it is the histogram. Feel free to always start, in case our first class is 49.5. So start from 49.5, go to 54.5, go to 59.5, and then start from how they are going. It is very fine. It is very fine. So it has no problem doing so. So in case this is 59.5, and maybe this is 64.5, it is very okay. Now for this one, when we are estimating the mode, always join this bar to this bar, join this bar to this bar, then come down here, read off the value you have. But we have said, how do you read off this value? Get the upper, which is 64.5, minus the lower, which is 59.5. Assuming here, there are just 5 boxes, 1, 2, 3, 4, 5. So here I would say I would divide by 5. So I get my calculator. Please do not forget to use your calculators, because some of you, at times you may think you know it all and you end up making a mistake. So I say 5 divided by 5, I get 1. So in case it has stopped here, then I'll count, I will say 59.5 plus how many boxes? That this is 1, 2 and a half. So here I will say 2.5 times each box contains 1. So then I say 59.5 plus 2.5, then I will get my answer that I'm going to write as 62. So that's how I estimate in case I have a histogram, in case I'm estimating for something. So that's how I can do it. But also for histogram, there is no problem. Some of you want to do this, but do not forget that this one shows you continuity. So you can start from here, that this is 49.5, this is 54.5, and then draw your graph the way it is. So if you start with continuity, then it means that along this axis, you can start from 0 and continue. But don't start from don't start from any other value. Here, better to start from 0, because this one shows us that you are starting from 0. Your graph starts from 0 onwards, and it caters for all the values you cannot write onto your graph. Okay, okay, Maluz Seed SS. Okay. Yes, Malud, ask.
So would I ask to go back? Now, would I ask to go back to the first question?
The first question?
Yes.
Okay. Yes, ask.
The calculation.
Oh, I don't have
the calculation.
it
here. The
here.
calculation on the median. A part of it.
Oh, okay, I don't have it. Okay, I don't have it on my screen, but you can ask.
It is under item 13.
Okay. Like what you want to see the thing or?
No, there's an error in the calculation of the median.
Of the median, eh?
Yes.
Okay. Let me stop sharing. Okay. Let me ask St. Andrew, can you share your screen again? I think their screen is on. St. Andrew's screen seems to, it is on, eh? Seems to be on. St. Andrew, let me stop sharing and I see your screen. I don't know why someone is saying there is an error. St. Andrew, share your screen. Okay. Malu's SS, hope it is there now.
Yes.
Okay.
If you are to check from the frequency distribution table, the frequency mode is there. And if you are to follow that row, you will get the lowest class boundary as 29.5, but not 39.5. On the calculation they use 39.5, but it's supposed to be 29.5. Since it's the lowest class boundary of the frequency mode.
Okay, now, okay, don't go off. Now I want to ask, yes? One, please take note, dear student, is that for you to get the law to use, to get that law you are going to use, remember you first get the position. So when you look at the position, they told you 50%. So 50% would be 50 divided by 100 times how many? And that was 40. So 50 out of 100, 50 out of 100 times 40, you get 20. So when you go to cumulative frequency, are you seeing where 20 is? Are you seeing? Are you seeing what they're highlighting there?
Yes.
So what is the lower class?
39.5.
Yes, 39.
39.5.
Yes. So that's what we use. Okay. Hope they are very correct.
But I'm confused.
Yes. What is confusing?
The way we were taught to get the lowest class band, you come and check the row that has the highest number of frequency. That's the frequency mode, then you follow that row.
Not really. That one applies for the mode. Eh? When you are getting the mode, that is okay. It doesn't apply for median. Have you got? That is for mode, not median. Okay. Stella Maris? Stella Maris? Stella Maris? So unmute.
Excuse us, sir.
Yes.
Yes, sir. So we some confusion. Like we had the question still about the data frequency table. We had the classes. The classes we had 10 to 20, 30 to 40, like that. Now, like it was like a guide, like a marking guide. Now they came to the class boundaries. Still, they repeated the same thing, 10 to 20. Yet we all know that for the class boundaries, we either have to add, like lower class, we subtract 0.5 and upper class, we add 0.5. So, like we are inquiring some more explanation about that.
Okay. I'm going to, So, it was, I'm going to answer. You said it had 10 to 20. Nsube, come again, had 10. I want to write it such that I can throw. Nsube, you can unmute.
It had 20 to 20, 20 to 30, 30 to 40, like that, and so on. Same applies to the class boundary.
Okay.
Same applies to the class boundary.
Okay. Let me see. Is my screen on?
Yes.
Okay.
Microphone.
Okay.
Yes.
Okay. Now, I want you to be very careful. I want you to be now very careful. Under what conditions? Okay, I think now when they're generating a class, we have what we call adjustment factor. That one, I don't want to take a lot into that, but we have what we call an adjustment factor. Now, when it comes to adjustment factor, so like you said, it was 20 to 30, then this was, okay, let me say 30 to 40, 40 to 50, something like that. I'm just using this as an example. Now, the moment you look at your values and you notice that these values here, these values along the diagonal are the same, it means that one you don't need to get anything like class boundary. When the moment you find that those ones are the same, it means that you don't need to obtain the class boundary. You use them the way they are. So how do we do it? Now, we have what we call an adjustment factor. Adjustment factor. So adjustment factor, we always get the lower class limit of the next class minus the upper class limit of the previous class divide by 2. Now, the moment this adjustment factor is 0, it means that one given is already a what? Is already a class boundary. So for this particular one, this is what we call the this is the upper class limit of the previous class, and this is the lower limit. So that means you have 30 minus 30, which is 2. So this will be 0 out of 2, which is 0. Now, the moment these ones are the same, and the moment your adjustment factor is 0, there is no need for you to get the class boundary. Take an example. When I have 10 to 14, when I have 15 to 19, when I have 20 to 24, to obtain that thing that we keep on adding, the 0.5, it means I'll get this one and this one. So it means I'll say 15 minus 14 divided by 2. So which will give us 1 out of 2, which is 0.5. So that's why for such classes, we add 0.5. So, but I want you to be very careful. So that one, we call it adjustment factor. So that question, probably it was beyond your level. If not, it had some error. But I want you to just go back and check whether these two were the same. In case they were the same, that is the reason as why they did not. Yes. Or at times, even at times, if you find when they're writing this, so also be very careful. If it is something like this, 20 less than maybe 30 less than or equal to 40, something like this. Or if they use this in quite a sign, then for that one, we don't get the class boundary because the adjustment factor will still be 0. So it was one of those conditions that they followed. So, but that one, it is beyond your level. So at this level, just stick to the easy ones. Those ones, you'll meet them at another level. But I wanted just throw more light where it came from. Okay, let me hope Nsuve, your question has been asked. Sorry, Nsuve, hope I have tried to answer what you wanted.
That is not your question.
Okay.
Have you answered your question?
Okay. Okay. Then St. Mary's Ediofe. St. Mary's Ediofe.
We want
we want to really inquire about whether if the inquire about the histogram. We want to inquire about the histogram whereby the two bars are all at the histogram whereby the bars are all at the same level. The bars at the same level. Then how do you estimate the bars when the okay, dear sir, we want to understand about when the two bars of the histogram are all at the same level. Then how do you estimate the mode?
Okay, I'm going to throw more light about that one. Okay, that one is what we call a bimodal. So when you have two, that one, we call it a bimodal. So I'm going to throw some light. Before we conclude. I'm going to throw some light on that bimodal, how we can estimate it. Okay, let me first hear from Itula.
Thank you very much. My question is about how we are going to arrange our classes when the values begin from 0 to 0.4, then 0.5 to 0.9 respectively.
I beg your pardon, 0 to?
0 to 0.4, then 0.04 to 0.4 to 0.5. 0.5. No. Oh, sorry. 0 to 0.4, then 0.5 to 0.9. Yes, I don't know how I'm going to come up with my class boundary.
Okay. Now, to come up with the class boundary, let me say this is your class 0 to 0.4, 0.5 to 0.9, and you are coming up with a class boundary. In order for you to come up with a class boundary, to know what you add and subtract, the first approach I'm going to give you is that you say 0.5 times 10 power negative n. This is what we call the error formula. Now, n stands for the number of decimal places. So where there is n is where you put the decimal place. Now, when you look at your numbers, this is 0. It can be 0.0. It is to one decimal place. So I will say 0.5 times 10 power negative 1 because it is one decimal place. So this will give you 0.05, meaning that in these classes you are going to subtract 0.05. So I will say 0 minus 0.05, which is negative 0.05. Then the upper one add, so you get 0.45. Here subtract 0.45. Here add 0.95. So when you find that your classes at one decimal place, then you add and subtract 0.05. In case it is to two decimal places, then you add, subtract 0.005. In case it is to 0 decimal place, then subtract, add and subtract 0.5. Hope that is okay. Okay, let me hope the school it is okay. Then Joel, Mukwai, and Selede. Okay.
Sir, you want to inquire about the distribution, okay, like the histogram. whereby we have two bars of the same height and at the
Hello,
highest.
I don't know whether you're getting me. Okay, come again. You are not so clear. Hello? Yes, go on. Go on. Go on. Kindly go on. Go on. Mr. Yes, kindly go on. I can hear you. I can hear you. Go on. Go on. Oh, okay. I think I'm fading. Let me first bring celery down.
Ours was about that when getting the summation, is it allowed to take the summation to the other line, like when getting the summation of f of x, then you put it of f of x in the line of frequency, and then you put the answer on the f of x line.
Okay. Now, in case this is f, so always better, you stick to 1. You say f of x is equal to, stick to that column. Stick to that column.
But the other ones put, they put in they placed in that row of frequency. The ones of St. Andrew.
Okay. Okay. But
yeah, let show that one. You scroll up and check. Scroll up.
You scroll.
Okay. Okay. I think okay. Okay. So, but the best is make sure you stick to that column. Stick to that column where your thing is. So there is no need for you to go on and have your answers in another column. So that one, make sure you stick to that one column that where you have your answers for the f of x. So there is no need. Okay.
Yes, I put the number.
Okay. Now, okay. Hope that is okay. 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 Last sent me Stella Maris and then Ediofe. Okay. Any of you can unmute.
Come.
So we wanted to know, like, when do we know that a question requires us to identify maybe the mode, the mean, or the median? Like, how do we approach such a question?
Okay. Now,
How
I'm
do we
going to
identify that a question requires mode?
Okay. 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 Now, yesterday, I think I had some highlights on those things. So, Nsube, I'm going to give you just a highlight. But yesterday, during the seminar, I was able to make about a 20 to 30 minutes talk about statistical graphs. So, I'm going to ask you, I may not give you everything, but if you can trace yesterday's program and then you just watch out that small clip that has statistical graph. So we say that when they give us the graphs, we have what you call 5 types of graphs. And those different types of graphs, we have graphs that are looking for a pattern. We have graphs that are about distribution. We have graphs that are about comparing. We have graphs that are used for estimation. We have graphs that are for comparative. So when we are looking for a pattern, all things that are going to give us a pattern, a trend, it means that we are looking for a line graph. When we are looking for things that involve distribution, then it means we are looking for what we call pie charts. When you are looking things for comparing things, then we are looking for a histogram. So each of those graphs has something, but yesterday I went on and gave it into details. So allow me to ask you to look out for yesterday's recording and check out for that part where I talked about the quantitative data and qualitative data. And I said that when it comes to qualitative data, we always use a pie chart. For quantitative, it can either be a histogram, a line graph, it can be a scatter plot. In fact, even we can have a scatter plot. For a scatter plot is when you have two variables that are changing. Let me say you have the value of the car and the price of the car. Since those two things keep on changing, that one will require to use a scatter plot. In case it comes to performance of math and biology, that one will require a scatter plot. But yesterday I was able to explain it into details. Unfortunately, I don't have that PowerPoint with me now on this computer I'm using. So I may not give you all the details, but in yesterday's seminar, maybe the teacher can help. Just get it is about, it was just about, I think it was after 1 hour into the seminar where I talked about it in details. But what you need to know, I gave even a sample question. I gave sample questions that they ask. And I said that whenever you find things of percentages, what are things estimating, things where they tell you over and below, then it means that you need a cumulative frequency curve. When it comes to questions that require to show how the things are going to be distributed, then that means you need a pie chart. When it comes to things that you want to look at, you are comparing, you want to look at the heights and the rest of that, then you don't need that. I will need a histogram. Things require optimal, that is a histogram. So, but yesterday I was able, in case you want to look at, to estimate, to predict things that require predicting over time, then it means it requires a line graph. But yesterday I was able to talk about it in details. Allow me to have Chibuka SS and St. Andrews SS Rugazi.
My question is, if your histogram has two bars which are of the same level, the highest bars when there are two, which one do you consider as your mode when calculating for the mode?
Okay. Now, okay. Now, when it comes to the mode, we have two different types. We have what you call bimodal. Bimodal means you can have two modes on your graph. And when it comes to the two modes, it means that it means that for that particular number, you are going to give two answers for your mode. Let me say you can find that these are the two bars, whereby this is one bar and this is the second bar. And now if those are your two bars that are tall, it means that, and maybe there is something here. Please estimate. Let me draw a line, come and read off the mode here. Come here, and read off the mode here. So it means that that graph will have two modes. So that one, read off both the modes and then give the both answers. So that one is okay. Take an example, you may find that the children, the performance of the children, the number of children who scored between 50 and the rest, and this are the same. So for that one, it is very okay to have both modes. So that one is really very fine. So you can easily find it. And then we may have another scenario. Let me say you find this, you find this, you find this, and something like this. Now, for this particular one, when you are finding the mode, what do you do in case the bars are the same? So now you consider this to be as you consider it to be like one bar. Then get this point, join it to the adjacent bar. Get this point, join it to adjacent. Then the meeting point. But this one, I think I'm going to emphasize it during the seminar and under what conditions, because such a graph is what we call we call it skewed left histogram. So, so we can say that it is skewed towards the right. But this one, I'll talk about it in details in one of the facilitations we have, because I want to first find out more scenarios that can bring out that kind of graph. But for this one, whereby they are separated, here read off both the modes. But when they are joined, I want to first find out a scenario such that I can be able to explain under what conditions you can get such a graph. But in case you meet it, it is still very okay. And now for that one, in case you find that kind of graph is in the middle, let me say you have drawn and it is like this, something like this. So this one is what we call a symmetrical one. In fact, we call it symmetrical graph. So it is very fine. You can find it. It is symmetrical. It can be found. But this one, I'll talk about it in details when we are into the facilitation week. After I want to first generate a scenario that can yield such a graph. Okay, I think we are going to St. Andrew Lugasi. Have you asked your question?
I was still asking.
Yes.
If also those two bars were together, but you have also explained about it.
Okay. Chibuka SS. Chibuka SS. Okay. Maganda Sanon, Madu SS, and Ediofe Girls. One of you should, as we conclude, I think we are going. Ediofe first. Ediofe ask.
Yes, sir. Will you throw more light about question 7 and question 17?
Question 7 and question what?
17.
Okay. 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 Now the rest. Okay. Let me first ask. I think Ediofe, you wanted question what?
Item 7 and item 17.
Okay, kindly tell me what is question 7 about?
What is it about? Question 17 is about loci.
Loci?
Question 17 is about loci.
Loci?
Loci.
Oh, loci. I have talked about it. Question 7.
Construction.
Yes, construction. It required you to have an equilateral triangle, which was measuring 10 centimeter 10, and then find which angle are you supposed to use. This one being an equilateral triangle, you need to know that if you label this side x, x, and this is x, all these angles are going to be also equal. So meaning that the angles inside here are equal. Okay, this was 10, 10. So if all the angles are equal, it means you say x plus x plus x is equal to 180. Then you say 3x is equal to 180, x is equal to 60. So they were testing, do you know how to draw an equilateral triangle when your angle is 60 and the sides are 60? Then also they were testing whether you know how to inscribe. So, and we said that when you are inscribing, it's just a matter of you bisecting the angles, and then you do it.
Okay, and then question 7.
Question 7, it was about, I think it is about patterns and algebra. It was under that section. So that one was about equations and knowing gradient. That is the topic. It was testing for equations. So you needed to know about even perpendiculars. I think there was something about perpendiculars, and then it was mixed with fractions. So it was about that. So where they told you a quarter of the length of the field, now you need to know that the field from one line to one line, they told you it was about, I think, 100 meters. So if it was a quarter, then you say a quarter of 100. Then get the position where that person was. Let me say was 25. That means that at that point, and they told you he was in the second line, or I think it was in the second line. That means that where he placed the point, it was 2 and 25 as your coordinate. Then after some time, they wanted you to draw a line joining the two. So you had to draw a line joining those 2 points. And I think they wanted something concerning drawing a perpendicular bisector, something like that. So that was the idea about it. So where they told you that draw the locus of points that are equidistant from both the green and the red. So when they talk about the locus, we know that locus, it means that the path being traced out will trace out an equal path. So whenever you have 2 points apart, the locus that is being formed between the two is always a perpendicular bisector. So this question was wanted to test, do you know how to draw a perpendicular bisector? So I expect you to come, locate where A is, locate where B is, the 2 corners, that is part E, and then come up with a perpendicular bisector. By placing your compass here, draw an arc, draw an arc, draw an arc up, and draw an arc down. Then you come up with that perpendicular bisector. And then the distance from here will be the same distance from this side. Have you got some hints?
Yeah, I've got, but can you use vectors?
Even you can use the idea of vectors. Most so where they said find length, you can use the vectors. Where they told you find the distance between the two and the rest of that, you can use the idea of vectors. It can work.
Okay, thank you.
Okay, or you can use where they have distance, you can use the vectors, or you can go on and use the formula for finding distance, x2 minus x1 squared, like that. Okay. Chivuka SS.
When you are drawing the frequency distribution table, can't you,
yes.
Yeah.
What is the question?
When we are drawing the frequency distribution table and we don't indicate the class interval, will it be correct?
Pardon? I beg your pardon?
When we are drawing the frequency distribution table and we don't include the class interval, will it be correct?
Okay. Now, there is no need for you to include the class interval in the table. For values that are constant, be it even in physics, never include them in your frequency distribution table. For values that are constant, that are not changing, in the table we put values that change. So there is no need for you to include it in your table. So they will just put irrelevant. That's what they will say. Okay. Maganda and Madu, unmute. Sanon? Okay. Madu, ask. Oselere, you are the last people, and then you. Oh, Madu.
Excuse me, am I being heard?
Yes.
Are you hearing me?
Yes.
Are you hearing me?
Okay, yes, go on.
I'm asking that for me, I used to know that in mathematics the percentage is always 100 and downwards or and below. But in a set theory, that is where I found when the percentage is like 160%. How does it come?
Okay. Okay, I'm going to answer that. Selere come also.
Sir, help us give us the coordinates of number 7. Part A, part B, and C.
Okay. Now, for number 7, I think I've given you one of the coordinates where they say a quarter. So the field was. So the field was 100 meters. So you can say a quarter of the 100 meters. So a quarter of the 100 meters, it means that this person had gone a distance of 25 meters. So now, and they told that he was in the second line. Being in the second line means you have 2 as your x coordinate, and along the y will be 25. So that's one of the coordinates.
Yes, sir.
Is that a scale we are going to use on the graph paper or what?
So now, is that a scale we are going to use on the graph paper or not?
Yes.
But sir, they say they divided AB into 10 lines, but the total distance is 50.
Okay. Now, what you need to know, first find out what is your A, find out what is your B, and then in case it requires you to have it on the graph, then go on and get an appropriate answer or a scale to use. Remember, you can use on your Y, you can use another scale. Please don't stick. Remember here, you can use the different scale. So you can say along the X, I'll use 1. Along the Y, I can say 1 centimeter represents 5. Then the person who asked about percentages, the answer is yes. The percentage of any quantity can be more than 100%. When they talk about percentage, percentage is a way of expressing any number as a fraction of 100. So when you say something is 100%, you are saying that it is the whole number. However, if it's more than the whole quantity, you can have a percentage that is above 100%. So you can have something, let me say 150 out of 100 items. Take an example. Let me say in case it was the original quantity. At times you may go into business and you like I think you have seen, let me use profits. At times profits may go beyond 100. Let me say you find yourself that in the business, you put in, let me say, you put in 20,000 and you make profits and you find that the amount you are getting is more than 50,000. So this one has gone beyond even what you put in. So meaning that you can even have a percentage more than 100. So it is very fine. It's very fine. It means just out of 100. That out of the total efforts you have put. Take an example. When you put in 2, like some of you read for 2 hours. So mean that the max for 2 hours, let me say you get 80%. So it means that you can even score more than the efforts you have put in. So out of 100, 100 means it is the whole thing. But what about beyond that? I think the questions are many. But lastly, Bridget, because I think you have not asked, then we cross it. Bridget.
Is it in order that I should write the title when I'm drawing the frequency distribution table? Is it that I have to write the title based on the question, or I can just write a frequency distribution table?
Better basing on the question you have at hand. You say a frequency distribution table showing this. And at times even it can help you. Some of us, when we are rushing into the exam, at times even we can forget to label. So for such cases, it can really be of help. Okay, I think we have gone beyond. We have gone beyond. I don't know, unless someone has a burning question. But allow me that I think let me ask that we end at this point. But let me ask the teachers, if you can kindly take some photos when those students are attending during the dark. Because I'm seeing Kubol SS in Koboko, it is really dark, but I'm seeing the child is still on. Kindly feel free to take for us some photos. And those who have their cameras on, kindly have your camera on. You can turn on your camera. I want to take some photos, but I know teachers are going to take for us some photos, but let me take some photos. Now, what are we going to have? Starting, we are going to have a program that is going to run for almost, it's going to run for 2 weeks. Yes. And how is this program going to run? From 4 onwards, starting, let me be sure of the dates, such that you can mark your calendars. You can mark your calendars because we want to ensure that you pass. So starting the week of 8th July, that is next week, 8th July, up to the 19th of July, we shall have facilitation seminars or sessions. we shall have for different subjects. We are going to come up with a timetable, but those sessions will be starting from 4 to 6 p.m. So we shall run for the first week. Let me say, today you may find we shall have biology. The other day we have chemistry. The other day we have history, like that. So we are going to bring all the subjects that we have not been able to have, and then we shall be able to meet. Then on the 13th July, after next weekend, we shall have chemistry seminar. It will happen, still to start from 9 up to around 1. But for it, we shall not have a Sunday session, but we shall have a Saturday session, such that we can at least get some energy on Sunday to continue with. Please charge. Yes, so that one is going to happen after next week. So starting the other week, so start recharging yourself, start loading, having data, and getting ready. That from 4 to 6, starting the week of 8, we shall have a session that will run for the whole from 4 to 6, and we shall be able to answer many of the questions that you'll have. Otherwise, I want to thank you so much for sacrificing your time. Yes, I want to thank you so much for sacrificing your time. Thank you so much, dear teachers and the school administration, for connecting these children for these online seminars. Thank you so much. We are really very grateful, and we are praying that for all the seeds that you are sowing, you may be able to reap abundantly. I want to assure the students that for any sacrifice you are making now, it will yield what you are looking for. In case you are looking for A's, you'll get them. Let us keep on sowing, and putting in the seeds. Yesterday, I told you, your friends, one of the stories that I want you to go up with from today. Now, and that story is about 2 people that I met. And those 2 people, one of them was called Frank, another one was called Solomon. And what really happened is that I was called by one of the head teachers in one of these schools. And what happened is that Frank, we had these 2 people. One of them was called Frank, and another one was called Solomon. So I had Frank and Solomon. These were teachers who joined the school in 2015. Now, when they joined the school, Solomon was earning 800,000. And Frank started with the same amount, still as Solomon, as 800,000. But at the moment, Frank is earning more than what Solomon is earning. Frank is now at 3 million, while Solomon is still at 800,000. Then Solomon went and complained and told the teacher, but head teacher, how come I'm earning low, yet Frank is earning more? And then the head teacher told him nothing, had no answer. So when the head teacher called me, I told the head teacher, let me give them the same task, such that we see the difference between who Solomon is and who Frank is. So what happened? We sent the 2 gentlemen to the market. Okay, give me a minute. Okay, so I sent the 2 gentlemen to go to the market, and I asked them to go and find out whether we have pineapples in the market. So when Solomon went, he came back and said, yes, there are pineapples in the market. Then I asked the second question, what are the prices of the pineapples? Solomon went on and went back to the market to ask for the price of the pineapples. So Solomon went back, he asked for the price, he came back that it is 3,000. But when I called Frank, Frank went and asked for whether I asked him the same question, go and find out whether there are pineapples in the market. So when Frank went, he came back and gave the feedback, and he said, head teacher, there is a gentleman selling pineapples in the market. Each pineapple goes for 3,000. Each slice of a pineapple goes for 1,000. Around him, he has a garden nearby. This garden has about 1,000 pineapples. And if you want to buy in bulk, he gives you a discount. If you want to do this, so that's how Frank answered. But the difference between the two, and is what I want us now to go with, that one of these people is an ordinary person. Another one is an extraordinary person. For any person or for any child who is going to excel in the new curriculum, you must be an extra person. Extra. So the way Frank answered, it is because of the extra thing that he's doing. So please, anything you are doing starting from today, find out something extra you can do. That extra thing, it can be the hard work you are putting in. In the new curriculum, you need to put in a lot of work. You as a student, put in that extra time, put in that extra effort, go and consult your teachers, go and do that extra number. So that extra thing is what is going to distinguish you from the ordinary people to an extraordinary person. It's going to distinguish you from the normal students to those students you call abnormal. Those students you look at and say, this person is really doing his best. And once you get that extra thing, it means you are going to be a better child, and I have no doubt that you will score highly. So today evening, sit down and ask yourself, starting today, what extra thing am I going to do? Am I going to manage my time well? Am I going to wake up early for prep? Am I going to be doing extra numbers to take to my teachers? Am I going to read differently? Am I going to something? So look for something extra such that at the end of the day, you are like Frank. Even when you are answering questions for the new curriculum, you are making a conclusion. Answer like Frank. When they ask for a conclusion, don't just say yes. Please answer like Frank. Say, basing on this, and this, and this. So don't just say yes and stop there. Your yes may not make a meaning unless you accompany it with other words. So please ask yourself, am I Solomon? Am I Frank? Let us do something extra such that by the time we come back here for another session, we have extra children. I want to end here, and I want to thank everyone for attending this session. Thank you so much for putting in all the efforts. I'm praying that all your efforts pay off, and I want to assure you, God will help you to succeed, and I want to assure that you will be successful in whatever thing you are doing. But I want to ask Insuve, yes, Insuve, kindly, can we have a volunteer? I know that one is a Catholic school. I don't know that they're still on the call. Okay, in case Insuve is not on the call, may I ask any volunteer from any of the schools to lead us in a word of prayer? Any volunteer, any person who wishes to? Okay, Ramadan, yes. Ramadan, you can. Okay, so I'm saying Saint Andrew. Who wants to lead us in a word of prayer? Okay, Saint Andrew, Vula SS. Okay, Vula SS, you can lead us. Kindly open your mic. Oh, Vula SS, you can unmute. You have the permission, I think. Your mic, you can unmute. Vula SS? Oh, I'm failing to get. St. Andrew Gombe, you can unmute in case you can. Oh, okay, Ramadan. Yes? Oh, St. Mary's Assumpta. Any school can lead us, no problem. Go on. Okay, God's Way High School.
I have a student here who wants to lead us with a closing prayer.
Okay, okay. God's Way, go on.
Yes. Please come and lead us. Yes, please.
Heavenly Father, we thank you for today. We thank you that you. Heavenly Father, we thank you for such a beautiful day. We thank you that you've enabled us with knowledge, you've always empowered us with everything. We thank you that you've always been there for us, and throughout this lesson, you've enabled us to understand. You've kept us through the lesson. Thank you for the teacher. Thank you for our administrator. Lord, I want surrender it to our please as we are going to home. May you come and may you guide us, may you give us protection as we are going. For this prayer and this in your name, Jesus Christ.
Amen. Amen.
Thank you so much, God's Way High School. We are really very grateful. Thank you so much, teacher. Teacher, maybe you can also greet us, Madam.
Hello, my name is Doreen Sachi. I'm a teacher of mathematics at Godsway High School, Maganjo. Thank you very much for organizing this session. We really appreciate it. Thank you.
Okay, thank you. Thank you so much for connecting. Let me pray that next weekend you can lead us, you can have a student to lead us in one of the numbers for pure.
Exactly. We are humbled and they will really participate. Thank you very much.
Okay, thank you so much. And bye, everyone.